Ses deneme. Ses deneme. Good morning, everyone. Today is the second day of our event. The first session is photogrammetry and remote sensing, the third session, which will be chaired by Professor Dr. Taşkın Kavzoğlu from Gebze Technical University. There are 6 presentations in this session, and everyone, today is the second day of our event. The first, sorry, I needed to close the YouTube live stream. And we will start with the introduction of the chair. Thank you again and welcome. And I hope all the presentations go well. So please, Dr. Kavzoğlu, please go on. Thank you.
Thank you very much, Mr. Secretary. Good morning, everyone. This is the second day of our symposium. It's Intercontinental Geography Information Days. We have 6 papers, as the Secretary said. I think one of the presenters is not around at the moment. He didn't show up. I think Haydar Akçay. He is the last one. That's why I think he'll join later on. I'll be giving you about 10 minutes for presentations, and then I'll expect to give someone to ask you questions, maybe 2 questions, 1 or 2 questions, if we have time. It would be nice if you could present yourselves just before your presentation. You can name your country and the institution. And for the first presentation, I'd like to give Adnan Yandra Nofrizel. His speech will be on prediction chlorophyll content of Zizania latiflua using hyperspectral data and machine learning. You may start.
Okay. So can I screen my PowerPoint?
Yeah, you can share your screen, yes.
Okay, good morning times of Turkey and good evening times of Japan, everyone.
Good morning, yeah.
My name is Adnan Yandrano Frizal from Shizuoka University, Japan, by the Bioresource Science Department, and I will present about my research with the title of Prediction of Chlorophyll Contents of Zizania latifolia using hyperspectral data and machine learning. So in the introducing, the firstly about the slag. In this research, slag will be used for the fertilizers. Slags largely consist of mixed oxides elements such as the silicons, an element that play important role in the metabolism of graminea plants. And Zizania latifolia is the graminea plants. For the information, Zizania latifolia is a same family of the rice, and the call is the Manchurian rice fields or the Chinese rice. And the relationships between the slag fertilizations and growth rates can be expected depending on the lower rates of the slag fertilization will find increased antioxidant enzymes activity and the chlorophyll contents, while the higher rates results in the reduction in the these physiological and morphological properties. Also, hyperspectral remote sensing is applied for monitoring biochemical based on the hyperspectral indicators and radiative transfers include of the chlorophyll. And after that, about the machine learning. Machine learning as a powerful tools for estimating agricultural in the case of the hyperspectral remote sensing data. And in this research, I use the random forest, but before the estimation use the random forest, we must do the analysis of the dimensionality reductions. And this research, I use the 3 of the dimensionality reductions. One is the principal component analysis, or PCA. After that, kernel principal analysis, or KPCA. And the last is the independent principal analysis of ECA. And what is the objective of this research? And in this research, the objective one is to evaluate the potential hyperspectral data for estimation of chlorophyll contents. And secondly is to investigate the best dimensional reduction methods among PCA, KPCA, and ECA. For the methods, one is the study area and measurements. Also, Zizania latifolia plants were cultivated within rows distance intergrowth spacing of the 100 centimeter on paddy fields at the Shizuoka University, my university, in the flow condition. And after that, in the second is the component of the fertilizations. And also the experiments include 4 types of slug, 1 slug, double slug, 2 times slug, 8 times slugs, and also compare with the without the slug, with total leaves that 200 and 40 leaf from each treatment. And this is image of the Zizania latifolia and the location of the slug fertilizations. And for the next, hyperspectral reflectance was obtained by using the field specs. So in this research, I use the instrument field specs, but in another research, in my laboratory, that's using the hyperspectral taking by the drone data. And for the analysis of the data, one is the measurement data divided into 3 groups. When we got a data measurement from the field spec, we divided the data to 3 groups. One is to training data sets, validation data sets, and test data sets with the 100 times repetitions. After that, genetic algorithms or GI based approach was applied to select effective wavelengths. And also, random forest machine learning will be using for the estimation of the chlorophyll contents. And before the run of the random forest, we use the dimensional reductions technique for include PCA, KPCA, and ECA. And this is the explanation about the PCA, KPCA, and the ECA. And lastly, for the statistical criteria with the RMSA, this is equation of RMSA. And this is the results. One if the, oh, I'm sorry, I mean that's chlorophyll contents. That's range from the 17.53 to 50x.02 milligrams. The maximum value were obtained from the 2 slugs. And then this is the spectral reflectance and their coloration. The first image, this is the spectral patterns for each treatment, and we see the control slug is the height of the reflectance, and the bottom is the correlation between spectral reflectance and the chlorophyll contents. We see in the 531 nanometer we got the REP, and in the 709 nanometer we got the REP too. That means this is the have a high correlation between the spectral reflectance and chlorophyll contents. Also, for the accuracy validations, by the PCA, KPCA, and the ICA, we got the best of dimensional reductions by the PCA with the mean of RSMA is 5.65. And also in the this image sounds about the relationship between estimation and measurement chlorophyll, and we got the coefficient of determination. The best is in the PCA2 with the value is 0.39, and in the bottom is image about the Taylor diagram showing the performance its dimensionality reduction methods, and the circle of greens it's that's mean near from the square, that's mean is the best dimensional reductions, and this is the PCA. And lastly, for the conclusions, this study was evaluated the three-dimensional reduction techniques for estimation chlorophyll contents from reflectance data, and for the results, we got the spectral reflectance as well zones control sample hikes reflectance values more than another slug fertilizer. However, PCA is the best method for dimensionality reduction for the estimation chlorophyll contents compare another advanced method such as a PCA and KPCA. And this is the reference of my research. And thank you for attention.
Thank you very much for Adnan for good presentation. Are there any questions?
We are waiting in the chat session and YouTube chat screen. You can ask your questions there.
I have a question for you
Okay.
while we are waiting.
It's pleasure.
Yes. You use genetic algorithms to select the best wavelengths, as you said.
Yes, that's right.
Which fitness function did you employ to find out the best? Because genetic algorithm is a search algorithm, but you need a fitness function.
Yes. Also, this is from
Which one did you use?
the software or like what?
The fitness function. I mean, when you are estimating the quality of the wavelengths that you are going to select, which method you used? Because genetic algorithm is like for searching, but to evaluate the quality, you need a function.
So before the GA, after that, I used the sums processing like
how did you select?
NV, FDR, first derivative reflectance, SNV, and I have a 5 with the original reflectance, SNV, and FDR, MSG, and just a 5 of that. Use the RStudio software.
When you are employing principal component analysis and others, how many of the components you selected? Because you know that when you apply principal components, if you have like 200 bands, wavelengths,
okay.
You reduce to 100 or 50,
just,
how many?
How
did you decide?
50, just a
50.
50.
You selected 50?
Yes, I selected
50. Okay, I didn't see that one, that figure.
Okay.
Any questions from chatting room?
I texted 2 questions from chat room.
Okay.
In the section, he can see the questions.
Oh yeah, for the question number 1, the zizania is can be it after the select treatments, because these treatments function to see the best fertilization for the Zizania latifolia. We know the Zizania latifolia, the goods of the silica contents, and if the silica increase, we can get the big of Zizania latifolia to eat. Especially in, maybe you familiar in the Chinese, he eat the Zizania latifolia.
Okay.
And question
Super.
number 2, I use the R especially RStudio. That is the familiar software now in the content is the
Yeah,
Python.
it is very popular at the moment.
Popular.
Yeah, okay. Thank you very much for good presentation, Adnan. And let's move on to the second one. The effect of auxiliary data, slope, aspect, and elevation on classification accuracy of Sentinel-2A image using random forest classifier. And the presenter is Furkan Bilucan. Furkan, you may start your presentation. You have 15 minutes. You have about 10 to 12 minutes for your presentation. Okay.
Hi everyone. Department of Geomatics Engineering. Also, my profession is remote sensing. Today, I am going to talk about our study, the effect of auxiliary data on classification accuracy of Sentinel-2A image.
Furkan, we cannot hear you. I think there's a problem. There's a noise. If we can check again.
Can you hear me?
Yes.
Can you hear me now?
It is better. Much better.
Okay.
Okay.
I continue.
Yes.
Hi everyone. I am Furkan. I am research assistant at Gebze Technical University, Department of Geomatics Engineering. Also, my profession is remote sensing. Today, I am going to talk about our study that the effect of auxiliary data on classification accuracy of Sentinel-2A image using random forest classifier. My presentation consists of 7 parts. First, use land cover definition, auxiliary data. 1 minute.
You can share your presentation.
My presentation consists of 7 parts. First part, land use land cover definition, auxiliary data, digital elevation model, slope and aspect, study area, random forest classifier, datasets, result and conclusion. Let's begin with land use land cover definition. Land use is a description of how people use the land and socioeconomic activity. Land cover refers to biophysical properties of the Earth's surface. Land use land cover maps provide irreplaceable information about the Earth's surface, and investigation of their accuracy has always been an attractive topic. It's known that the accuracy of LULC maps could be improved using auxiliary data. In our study, Sentinel-2A data was used. Therefore, auxiliary data refers to any geospatial data that is not derived from Sentinel-2A satellite image. Also, inclusion of auxiliary features can improve the classification accuracy. There are many auxiliary data used to improve classification accuracy. One of them is the digital elevation model. High topographic change could cause pixels belonging to same class to have different spectral values, and pixels belonging to different classes to have similar spectral values. In this case, it brings about decrease in accuracy to occur during the classification process. In light of this information, the main purpose of this study is to investigate them, which has a positive effect on thematic maps classification accuracy. Digital elevation model is a digital model or three-dimensional representation of a terrain's surface created from the elevation data. Slope and aspect, which are the main characteristics of the land surface, are extracted from them. As you can see, the study site has elevation values ranging from 40 to 1,637 meters. Slope is the angle of between any topographic surface with the horizontal plane. The slope in study area varies from 0 to 70 degrees as shown in figure. Aspect is defined as the orientation of the Earth's surface with respect to the Sun. It can be thought of the slope direction. In the aspect map produced for the study area, flat region were represented by -1 degree, and aspect map delineates 9 geographical direction as indicated in figure. The study site covering an area approximately 537 square kilometer length is located on Kocaeli province in Turkey. The study site basically covers 7 essential LULC classes, namely forest, bare and soil lands, road, water, urban, cultivated and non-cultivated. In accordance with the aim of study, 700 train and 300 test pixels were selected per class to produce thematic maps considering pixel-based image classification methods. Random forest is based on the principle of using decision trees. The main purpose of RF classifier is to create multiple decision trees using bootstrap sampling method. The training dataset used to create tree models in the decision forest is randomly selected from the original training dataset. Approximately 2/3 of the randomly sampled dataset is used to create the decision tree structure, and the remaining part is used to test the validity of created decision tree model. That dataset, 10 data at 12.5 meter spatial resolution was obtained from the Alus-Pulsar satellite and employed in this study. The spatial resolution of the Sentinel-2A image bands were converted to 12.5 meter spatial resolution by resampling method to combine with the topographic features. 5 datasets were created to evaluate the effect of elevation, slope, and aspect on classification accuracy. Dataset 1 includes Sentinel-2A image bands. Dataset 2 was created by adding the slope feature to the dataset 1, as you can see in table. Dataset 3 is obtained by adding the aspect and features to the dataset 1. Dataset 4 was produced using dataset 1, including spectral bands and elevation map. As you can see in table, dataset 5 was created using a combination of Sentinel-2A image bands together with topographical features of slope, elevation, and aspect. Result and conclusion. In order to examine the effect of the auxiliary data on classification accuracy, random forest classifier was applied to the constructed dataset, and it was revealed some important finding. It was observed that the highest classification accuracy was estimated 96.19% overall accuracy using dataset 5, as you can see in the overall accuracy and kappa table. The second highest overall accuracy result was estimated 96.10% using dataset 4. Results indicated that accuracy increased when elevation and slope features were used as auxiliary data. It was found that elevation is the most informative and compared to other topographical features, considering difference in classification accuracy. Results noticeably indicate that accuracy increased when elevation and slope features were used as auxiliary data. It should be highlighted that aspect feature did not contribute to solution by slightly decreasing the classification accuracy. This is the result image. This is the result thematic map produced with the highest accuracy. So this is a high accuracy, 6.19%. As you can see. Thank you so much for your attention. My presentation.
Thank you, Furkan, for presentation. Do you have any questions? You can, if you like, you can write your questions from the chatting section. Any questions from the meeting room? Furkan, I can ask you a question while we are waiting if anyone asks. Did you apply feature selection algorithms and look at their performances?
I didn't apply because I wanted to step by step as a raster slope aspect and other elevation.
How many parameters did you employ? Did you use in the study? Totally.
I apply it in classifier or raster.
In classifying, how many parameters you had?
I have I applied 3 parameters.
Okay. In addition to spectral bands, I think.
Yes.
Okay.
Sentinel-2A spectral bands, 10 bands, 4, 3, 4, 5, 6, 7, 8, 8A, 11, 12.
Okay. I think there is no question.
No questions received.
Okay. Thank you, Furkan, for your presentation.
You're welcome.
Let's move on. And the third presentation will be presented, I think, Nayalin Form. Mangrove forest changes and response to sea level rise based on remote sensing in GIS in PKWS, Cambodia.
Can you hear me?
Yes, we can hear you.
Okay, let's start.
Yes. Okay.
Can you see my slide?
We can see it now. No problem.
Okay, good morning, everyone. My name is Panayalin, and today I'm gonna present about the mangrove forest chain and respond to the sea level rise based on remote sensing and GIS in Pingprasam Wildlife Sanctuary in Cambodia. And this is my outline that we will start from the introduction first. So Cambodia is the country that we can find a lot of mangrove forests along the coastline of 435 kilometers. They consist of 4 provinces that you can see in the map. They include Kokong province, Sehan Ria, Pompot, and Kai province. And the coastal mangrove area in the Kokong province has been lost about the 69% between 1989 and 2017. And this coastal area is the area that we can be impacted and straight to the future sea level rise that caused by the climate change. And for this sea level rise can lead the significant impact to the mangrove ecosystem. That's why until now, the integrating of remote sensing and GIS can provide new techniques to study about the mangrove forest and also can analyze the relationship between of the mangrove forest and the impact of the sea level rise. That's why we come up with the 3 objectives. The first is we want to extract the mangrove forest from 2015 to 2020 using the multi-temporal data that derived from the Sentinel-2 image with the random forest classification. And second, we will analyze the mangrove forest chains from 2015 to 2020 using the models in the QGIS. And the last, we want to assess the vulnerable area of the mangrove forest under IPCC sea level rise scenario using the geospatial model. And for the study area, we select in the Pingprasam Wildlife Sanctuary in the Kokong province in the southeastern of Cambodia. That this area is concerned about the clearing of the mangrove forest by the human activity, and also the area extremely vulnerable to the climate change, especially its rising sea levels. And this is my methodology workflow design. So for the data that we have to use, we include of 10 met Sentinel-2 image that start from 2015 to 2020, SRTM dam, boundary data, and sea level rise scenario with 3 different 40 centimeter, 60 centimeter, and 1 meter. And for the mangrove extraction, we will use the Sentinel-2. Before classification, we have to apply the atmospheric correction to make the data more reliable and accurate. And then we will perform the easy random classification in a Desert Saga plugin in QGIS that we have to running the random algorithm training with 240 samples per satellite image, total of 6 class. And then we will get the land cover class with 3 levels from 2015 to 2020. And next, we will be analyze the land cover in level 1 of mangrove forest chain using the models by calculate the changing of the land cover class from mangrove to other land cover class. And then we will create the changing of the mangrove forest map. We will get the mangrove forest chain map in 2015, 2020. And the last, we will process the mangrove vulnerable to the zero rise scenario by create the geospatial model based on the SRTM dam and zero rise scenario. After that, we will overlay with the mangrove forest area result in 2020 to create the inundation map. And this just shows the full workflow of methodology. Okay, let's go to the result. So this is the land cover map level 1 in Pimcosan Wildlife Sanctuary. They include of 6 class, include of water body, mangrove forest, sawmass, forest land, settlement, and other land. And the second one is the land cover class level 2 that include only 3 classes that we keep the water body and mangrove class the same. And for the non-mangrove forest, we have converted or combined from the sawmass, forest land, and settlement and other land into the one class as the non-mangrove forest. And the last one is the mangrove forest map from 2015 to 2020 that we keep only the mangrove forest map that you can see in the green color. And this table just show about the land cover class from 2015 to 2020 in area of hectares and percentage. And if you look at into the graph, we can see that in the Pimcosan Wildlife Sanctuary, mostly covered by the forest land, followed by the mangrove forest, water body, settlement, sawmass, and other land. And this is the map that shows about the mangrove forest chain in Pimcosan Wildlife Sanctuary. That you can see that in 2017, 2018 is the year that mangrove have been significantly increased about 19.21 hectare, and for in 2017 it's decreased about 157.74 hectare. And for the blue color is the area that have been increased of mangrove forest. And this one just show about the 5 year of mangrove forest chain in Pimcosan Wildlife Sanctuary, that we can see that the unchanged mangrove is totally about 6,281.89 hectare, and it have been decreased about 561.59 hectare, and have been regrown in the study area about 451.91 hectare. And for the total change during 5 years from 2015 to 2020, we can see that it has been decreased about 112.26 hectare in Pimcosan. And the last one is about the potential inundation of the sea level rise on the mangrove forest area. If you look at the table and the graph, we can see that if sea level rise by 40 centimeter and 60 centimeter, the mangrove forest will be vulnerable area of 40.44 hectare, and it can be reached by 53.14 hectare by sea level rise 1 meter. And the map also shows the area that mangrove have been vulnerable to the future sea level rise. And you can see that mostly the low-lying area is the place that will be vulnerable to the future sea level rise. Okay, let me conclusion. So in this study, we can conduct the accurate mangrove forest map by using the 10 map Sentinel-2 imagery with combined with the random forest classification in the DCSACA plugin. And we also can analyze the mangrove forest chain during 5 years using the models in the QGIS. And this study also provides a new knowledge how to apply the GIS and remote sensing to analyze the vulnerable area of the mangrove forest due to the sea level rise based on the GEO model that we create from the SRTM dam and IPCC sea level rise scenario. Okay, thank you for your pay attention. If you have any questions, please feel free to ask. Thank you.
Thank you. Thank you. Any questions? We expect questions. You can ask from the meeting room and chatting. You can write down your questions to our presenter. In the meantime, I can ask a question.
Okay.
As far as I understand, there is a threat for mangroves if the sea level increases.
Yes.
Do you think that in the near future they are under a great threat, or what's the prediction for the future?
This projection is at the end of 21st century. They're based on the IPCC RCP 8.5 scenario.
Mm-hmm.
Yeah, that we can see that if sea level rise by 40 centimeter or 60 centimeter, my study area will be vulnerable about 40.44 hectare over there.
Okay. When
And
the
it
sea
can
level
be,
increases about 1 meter,
it will be reached by
Yeah.
53.14 hectare over there.
Okay, this is a significant loss, I think. Huh?
Yes.
Okay.
Do you have
Any
question?
questions? Any questions?
No questions received, Professor.
Okay, thank you very much for attending.
Yes, thank you so much.
And very good presentation.
Thank you.
And we are moving on now. And I think Abubakar Sani will be presented. I saw his name. Effect of elevation on land surface temperature variation in Jos and environs in Nigeria. Abubakar, you can start your presentation. Good morning. You can start your presentation now.
Good morning. Can you hear me?
Yes, we can hear you now.
All right. Let me share my screen.
Okay.
Good morning, all. I'm Abubakar Bello from Nigeria, and I'm going to present our paper, The Effect of Elevation on Land Surface Temperature Variation in Jos and Environs, Nigeria. So my co-author is Abubakar Sani, and he's together with us. The content of our paper are introduction, statement of research problem, study area.
Abubakar, it is better you start your presentation.
All right,
screen.
so that
full screen.
All right, so that to save time.
Yeah.
All right. So currently, rising of temperature is one of the major problems as a result of climate change. And as we all know that relief has some effect on modifying climate when it comes to orographic rainfall or relief rainfall and environmental lapse rate, which is decrease in temperature as the with increase in elevation. So Jos is one of the area of high elevation in Nigeria that is located in the north central Nigeria. So it is source of many rivers like River Kaduna, River Sokoto, and other rivers. So the statement of research problem, land surface temperature is the skin temperature of the surface, which can be measured remotely using sensors. As a result of increase in temperature of the surface, it affects the air temperature that make the air to rise up. And this causes some health problems like heat stroke, heat cramp, heat-related mortality, among others. For example, in the United States, from 1979 to 2003, over 8,000 people died as a result of excess heat. So it means there's need to investigate the effect of elevation because people are moving from areas that have higher temperature to areas that will have lower temperature so that it will become a comfort zone for them. So that is why we want to investigate the effect of relief in land surface temperature. The study area is located in north central Nigeria, and our study area comprises of 4 local governments in Plateau State, which are Jos North, Jos South, Basa, Riom, Barry Kiladi, and Jos East local government, which form our study area, with a size of 5,324.62 kilometer square. So as a result of the high elevation, the climate is tropical climate, but it is unique as a result of the high elevation, which is like temperate climate, which is almost has low temperature throughout the year. This is the map of the study area. You can see the map of Nigeria, map of Plateau, and our study area. Methodology. In this research, we use satellite imageries from SRTM, which we use to generate the digital elevation model to show that the relief of the area. And we also use Landsat 8 of 2020, which we downloaded from United States Geological Survey website. So we use this to generate the land surface temperature map and the elevation map, which we use for our research. Then finally, we use correlation analysis so that to investigate the relationship between relationship and land surface temperature. The method we use in retrieving the land surface temperature is single channel algorithm, because Landsat 8 has two thermal bands, which are band 10 and band 11. But it is better to use band 10 because of the noise in band 11, because a satellite that has two thermal channels, it is better to use split window. But this one, it has some noise that may affect the accuracy of the calculation. So that is why we use single channel algorithm. So our result, which you can see in the map, shows that the elevation of this study area range from 550 to 1,800 meters above the sea level. And the high elevation area is found in the eastern part of the study area, while the surrounding of the study area, most especially the northern part, has lower elevation. So after this, then we generate our land surface temperature map. So you can see that the areas of high elevation in the north and the eastern part of the study area has lower temperature because of the relief, while the northern part has higher land surface temperature, and the surface temperature range from 19 degrees Celsius to 35 degrees Celsius. This 19 degrees Celsius is found in the eastern part. You can see it in blue color, while the highest temperature, which is 35 degrees Celsius, is found in the northern part of the study area as a result of the lower elevation. So our relationship between relief and land surface temperature shows that there is a negative relationship, which means that increase in elevation lead to decrease in temperature. And the correlation is 0.19, which is weak correlation, which is weak result. So this may be attributed to the nature of the relief, because we need to consider the angle of the sun, we need to consider the land cover and land use, and we need to consider the climatic condition. This may affect the relationship between the elevation and the land surface temperature. Thank you for listening.
Thank you, Abu Bakr.
All right.
Very good presentation. And first, any questions from the meeting room? No questions. No one? Okay. Abu Bakr, thank you very much.
All right. Thank you so much, sir.
Okay. The next presenter will be Hong Lei. He will be presenting his research. His research title is Application UAV-based multispectral images for assessing oil palm trees, health using online artificial intelligence platform, the AI platform. Okay.
Yes. Excuse me, Sir Abu Bakr, please stop
Abu
your
Bakr, yes.
screen.
Can you just stop your presentation? Then Hong Lei can present. Okay.
Okay.
Okay. Now we can see your presentation. Yes.
Okay, let me start. Good morning, everyone, and good afternoon from Cambodia. My name is Lai. I come from Cambodia. I'm a master student at Botopha University and University. Today, I'm going to talk to you about my research topics on application of UAV-based multispectral images oil palm tree health using online AI platform. My presentation will be divided into 5 parts as the following. First, look at introduction. The rationale of research oil palm is now a major source, sustainable and renewable raw material for the world foods. I also define the problem evaluating health and replace that of the oil in the large area is too difficult to replace and estimate the oil palm tree in the large scale. And problem solving. I implementing spectral camera sensor for evaluate oil palm tree health by using UAV mapping and vegetation index. For the second part, summary of research design. For specific objective, the first objective to detect and count oil palm tree of very high resolution images from UAV with an online AI platform. And the second one to evaluate and compare oil palm tree health by using NDOE, GNDVI, and NDVI index in vegetation and field content. Okay, for the methodology, the study area is located at Investment Cambodia Oil Palm Co. Ltd. The area of the oil palm at the Monetary Investment Cambodia Co. Ltd. The area is cover 1,012 hectares at Sihanoukville, Cambodia. Okay, let's move to the research frameworks. The first step, data collection. First, I collect the raw image by using UAV, and then I process the image. After that, I will get the high resolution image, and then get multispectral images. The second step, object extraction. I use AI online platform to extract the objects. After that, I evaluate oil palm tree health. Software application and VIs. For the software, I use drone to capture the raw image, and I use the software DJI drone deploy Page4D. For the object extraction, I use Picture platform to detect and analyze. For the oil palm health estimation, I use NDOE, GNDVI to evaluate oil palm tree health. And the software I use ArcGIS and ArcGIS-Pro. Okay. For the multispectral band of oil palms, you can see here there are 4 bands of the multispectral. The first one green, red H, and the last one near infrared. After I train the data, I get the reports from the training sample. As you see here, it's the training sample that I get from the first plot and the second plot. And I move to the experiment result. For the part 1, oil palm extraction based on AI platform, I extract the object extraction by using AI platform. You can see the result. For the accuracy assessment, based on F score, is up here 100%, and the second plot is up here 98.967%. For annotation, 141, and for the second plot, 142. Annotation refer to the training sample number. Okay, let I explain the detailed missing and different detection. For missing detection, I can find there are 2 And for the second plot, I can find 1 and detect different objects 7. And for the second plot, I can find 14 objects. For the object detection is, you can see here, cannot detect because of the image maybe is blurred. And for the object detection is similar to the oil palm tree. You can see here it detects 3. Okay. For the second part, counting oil palm, UAV based very high resolution imagery. After I extract the objects, I can count the number of the oil palm tree. Okay, I also count the number by using automatically and manually. You can see here the result and the difference of the number of oil palm tree.
I think you mistakenly closed your presentation.
Maybe I have some problem for
Yeah,
my
can you
PowerPoint.
try to share it again?
Yes,
Please?
I can. I can see it. Just wait a moment, please.
Okay, no problem.
Yeah.
For online presentation, this can happen, no problem.
Okay, continue. For the oil palm estimation, here is the map show the oil palm tree health by using NDOE. NDOE can estimate chlorophyll and leaves of the tree. Here is the result of the oil palm tree estimation by using GNDVI. For the GNDVI, I can know the water and nitrogen of the oil palm tree. Here is the result of NDVI. NDVI is, I can plus the unhealthy, moderately healthy, very healthy of the oil palm tree in both plots. For the part 4, spectral signature of oil palm tree health. After I evaluate of the oil palm tree health, I can identify the spectral signature of oil palm tree with the 4 bands. I collect 4 points of the oil palm tree of the unhealthy, moderately healthy, very healthy. You can see here for the unhealthy, it's very low reflectance and also low reflectance at the infrared. For the second plot I can identify for the moderately healthy and very healthy of the oil palm tree. Okay. After I estimate oil palm tree and then I go to field to change the oil palm tree situation. You can see here that for the first plot and the second plot. I also compare the vegetation index for the first plot and second plot, NDOE, CNDVI, and NDVI plus 1. Okay, here is for the comparison of plot 2. Okay, let me conclude my presentation for today. For the counting and detecting oil palm, UAV-based very high resolution imagery are very important for count the number of the oil palm tree. And the platform is good performance of accuracy assessment is appearing over 100%. For the oil palm tree estimation and classification, As you know, multispectral images is very important for estimate the health of the tree. Also can know the nitrogen, water absorption, and chlorophyll of the leaf of the tree. Is my activity of my research at field. Thank you for your attention. If you're interested in my research, you can contact me by email and IG below. Thank you so much.
Thank you very much, Lei. Any questions? Question for Mr. Lei. Could you tell us the central wavelength and spectral bandwidth or multispectral bands? Can you read the questions?
I cannot get this point. Can you explain me for this question?
I think you use the drone data, hyperspectral data, I think, no? You use the drone to take the pictures, take the digital imagery, and he is asking the bands that you employed in this one. How many bands, or you know the central band? Can you give information about the bands you use, spectral bands?
For the drone mapping, I use there are two sensors. The first sensor is called Seguya sensor, and the second one is called IGD sensor. After that, I get different raw image. For the RGB imagery, I process for the high resolution images to detect and extract oil palm tree. And for the second camera, I use Seguya, and then I will get multispectral. There are 4 bands of the multispectral, so I can estimate the oil of the palm. Yes.
Okay. In your presentation, just before I think the conclusion, you presented a figure about the comparison of NDVI, GNDVI.
Yes.
Did you mean, you didn't explain which one was better in your study? I mean, NDVI was the highest. That means that it was better in your study?
Yes.
You didn't point out that one. That's why.
I compare.
Is it correct that I interpret like that?
NDVI. Yes. NDVI is better you another vegetation index. Yes.
Okay. Compared to the other ones, it was higher. That's why it was higher in the
compared to
diagram. Yes.
Yes, the higher. Yes, the higher.
Yeah, I think it's much more suitable in the way. Yeah. Okay. Any other question?
Yeah.
No. Thank you, Honglei, for your presentation and for joining us. And I think it's the last presentation, today's first session. Will be presented by Haydar Akçay. And the title of his speech will be Sentinel-1 and 2 time series data fusion for olive tree identification in heterogeneous land surfaces using Google Earth Engine. Haydar is here, I think. Yeah.
Yes, I'm here. Good morning and welcome to my presentation. Today I'm going to present our latest work about the time series data fusion for olive tree data identification. How many minutes I have?
You have about 15 minutes.
Okay. So let me talk about olive trees first of all. Olive is one of the most widely distributed crops around the world, and it's cultivated in each continent. It's very crucial for the economies of Mediterranean countries, And for this reason, we can consider it as a strategic crop. For a strategic crop, it's important to identify or determine the number or the special geographic extent of the these trees and its product. And it is the fourth most produced fruit following grape, apple, and orange in Turkey. Olive production in Turkey is ranked fourth in 2017 with 2,100,000 tons, according to Food and Agricultural Organization. It's primarily a family business, and 320,000 families live off olive production. It means more than 1 million people live off with this industry. And this is the map of olive tree special extent in Turkey, according to the Cooperatives Directorate General. When we come to our study, the study area is in Izmir, and it's the region between Bayındır and Three districts. The north and the south sides of the landscape are mostly mountainous and have heterogeneous plantations, olive trees, sparse vegetation, bare land, and forest. Forest means different type of trees in this region. In the middle of the site, mostly covered with agricultural lands. In this area, we selected 90 olive orchards for sampling, 90 olive orchards, 70 agricultural parcels, 60 urban area, 30 forest area, 20 bare land, and 20 sparse vegetation fields. We pay attention to the select these from all the region, not concentrate a specific place. 70% and 30% of the sample sets are separated and used independently to train the random forest classifier and validation of the classification. We used Google Earth Engine, which is a cloud-based planetary scale geospatial analysis platform. And we use Sentinel-1 images and Sentinel-2 images. Sentinel-1 images operates, we selected interferometric widescreen mode, SWAT mode, and this operates in C-band synthetic aperture radar and provides dual polarization with VH and VV ones. This data is calibrated and auto-corrected ground range detected scenes using Sentinel-1 toolbox in Google Earth Engine platform. And Sentinel-2 level 2A images are atmospherically corrected and provide a bottom of atmosphere reflectance values. It has 12 spectral bands. We selected, we accessed 42 Sentinel-1 and Sentinel-2 satellite images, 21 image for each satellite sensor between 2019 and 2021 in two-year period. Closest image dates of each satellite were matched, and then we stacked this data. Also, actually, one of the most important part of this study is we generated a new ratio index, which we use DBI index and red bands, because when we work on olive trees, we realized that DBI index and red bands give distinctive reflectance when we compare to other classes in the region. Also, we calculated 9 more different index. You can see these indices in the table. there are NDVI, NDVI red edge, blue green red ratio index, DVI, NDTI, SAVI, NDBI, BCI, radar vegetation index, RVI, and our found DVI R index. You can see the formula of that index as well. And we conducted a random forest classifier to our data set, which is a modern approach proved to perform fast and accurate for large and variegated data sets. And it uses classification and regression trees as a working principle. We paid attention to select the cloud-free images for Sentinel-2 satellite, but not all of the sites are cloud-free. For this reason, we applied a cloud mask to image collection, and these parts will be seen as white in the classification image, which I will represent at the end of the presentation. In the next step, Sentinel-1 and Sentinel-2 bands and calculated indices were combined. It means 21 dates for Sentinel-1 bands indices and 21 Sentinel-2 bands indices. In total, 21 dates with 25 bands indices. It means 525 layers. But we make different stack combinations. For example, Sentinel-1 standalone stack, Sentinel-2 standalone, Sentinel-1 with Sentinel-2 stack, Sentinel-1 with DVI red index, Sentinel-2 with 9 index, spectral indices, and like Sentinel-1, Sentinel-2, and indices. And we applied random forest classification to each stack. As I mentioned before, 70% of the samples were used for the training, and the 30% of the samples were used for the validation. And also, I mentioned this before, we use these data sets independently. Results show that DVI red index standalone classifications succeeded 84.4 users accuracy for olive class, since we experiment the performance of this index for olive trees. But this is less accurate than RGB ratio index and bare soil index, which we observed. Sentinel-1 standalone stack and radar vegetation index gave the lowest users accuracies as we expected. But impressively, Sentinel-1 data when stacked with DVI red index, it increased the accuracy remarkably and performed the highest users accuracy for olive class, as you see in the table. When we look at the overall classification accuracies, Sentinel-1, Sentinel-2, and 10 indices fusion succeeded the highest overall accuracy with 95.5%. Sentinel-2 with DVI-R and Sentinel-1 and Sentinel-2 and Sentinel-1 with DVI-red stacks performed slightly lower accuracies with 94.9, 94.7, and 94.2% respectively. DVI-red standalone classification performed the highest overall accuracy when we compare to the rest of the standalone index classifications. And overall accuracy of DVI standalone classification performs slightly higher than its combination with Sentinel-1 and Sentinel-2 stacks. We can maybe say that this results show the effectiveness of DVI index in land cover land use mapping, but this study cannot show this result now. We need to make a comprehensive study in a different regions and maybe more bigger regions. Also, we can say that multi-sensor data fusion significantly increases the classification accuracy of SAR data. And this is interesting. Only one optical index can improve the accuracy of SAR data more than 50%. This index is DBI red index. When we combine this with Sentinel-1 data, it performed 97.2 classification accuracy, but Sentinel-1 and DBI red standalone classifications remained at 55.5 and 84.4 respectively. So when we combine DBI red index with Sentinel-1, the standalone DBI red index classification improved almost 15%, but when we base the Sentinel-1 data, it increased more than 50%. This result also explains the efficiency of SAR data when fused with optical indices. And also we can say that it's obvious that DBI red has a significant role in identifying olive trees. Also, we should note that the positive effect of time series data is also clear in this study because we use very high data sets in a time series. And when we check the confusion matrix of Sentinel-1, Sentinel-2, and 10 indices data fusion classification, olive mostly mismatched with olive forest class as we expected because different tree groups, including olive, can be located in the same field. I'm going to show a figure which shows this misclassification. Bareland mismatched mostly with urban and sparse vegetation. And when we look at the users' accuracy and producers' accuracy, and when we compare this, there are large discrepancies between users and producers' accuracies of forest and sparse vegetation classes. We think that this is caused due to lack of samples for these classes because just 20 samples per each class be selected for the whole study. And when we compare, I think it was around 90 olive trees. Yes, 90 olive orchards. These are not just one point. These numbers represent the sample polygons. And this is our classification image of Sentinel-1, Sentinel-2, and 10 indices data fusion. When we zoom to this region, we see a heterogeneous land surface with all classes. When we look at the circle A, this shows a group of trees which are correctly classified as forest here. And when we look at B, there are misclassifications with all classes because it's very mixed place here. And C also shows correct classification of urban and olive fields here. This is a building classified correctly and olive orchard classified correctly. This is all what I present. Thanks for your listening.
Thank you, Aydar, for a comprehensive study and a good presentation. We can have, I think we have only 2 minutes left, but we can have questions. Just a quick question from me, first of all. Did you apply any speckle reduction algorithm for the radar data? No?
No.
Have you checked your imagery? Is there any speckle or any other problems?
I think I didn't check, but I think there is speckles inside it. I didn't know how to make speckle.
I think you should use
Because I work in Google Earth Engine, I will research it and I will make a comprehensive work.
you can use a
for-
leaf filter, for example.
Yes, yes,
It's a simple one and a fast.
yes, it's
Okay.
possible. You are right.
Yeah. You can increase your results, you know, it will be better for the accuracy.
Yeah.
Any other questions? One last question, no?
No questions received, Professor.
Okay, thank you. Then I can conclude this great session. Today's photogrammetry and remote sensing is ended now. I'd like to thank all the presenters and joining us today. And a special thanks to our secretary, Can, and the organizer, of course, Professor Murat Yakar. I'd like to thank him for a great organization again.
Thank you so much, Professor. You know, it's so glad to have you here as a chair, and we are looking forward to having you again in the following events. Thank you so much.
Yeah, I appreciate it. Thank you very much. Okay, have a great day and hope to see you again. Okay.
Thank you. The next session will start in 15 minutes. So I'm concluding this session and I will assign the other panelists. Thank you.
Okay, thank you. Thank you, Can. Bye-bye.
Bye. Good morning.
Nasılsın?
Good morning, dear participants. We are online on YouTube and Zoom, and now we have the second session of Geographic Information Systems and Cartography, which will be chaired by Professor Dr. Hande Demirel from Istanbul Technical University. We have 6 presentations, and except one of them, all the panelists are ready, and by the time he enters into Zoom, I will assign him as a panelist. The session is yours, Prof. Thank you.
Okay, thank you very much, Professor Ivan. So welcome to the second session of Geographic Information Systems and Cartography. I'm very delighted to be here. So I'm coming from Istanbul Technical University, Department of Geomatics Engineering, and so my expertise is on GIS. So I am very happy to meet you all. So I would like to give the floor to the first presentation presenters. The title is Temporal Analysis and Future Prediction of CO2 emissions of solid, liquid, and gas fuels in Python with FPB profit model. I think Mehmet Emin Tabar is going to present this valuable contribution. So please keep in mind we have 8 minutes, 10 minutes to present it. And then we will take some questions through chat during the presentation, and afterwards we could have a questions and answers session for all presenters.
Hi, I'm Mehmet Emin Tabar. I'm going to talk about temporal analysis and future prediction of carbon dioxide emissions of solid, liquid, and gas fuels in Python with FP profit model. The concentration of greenhouse gases caused by humans in the atmosphere started to increase, especially with the industrial revolution that started in the 1850s. As a natural consequence of this, an increase in energy demand has been observed, and a significant increase has been observed in the use of fossil fuels and compensate this increase. When we look at the air temperatures in the period from the 19th century until today, the air temperature has increased by 0.5 degrees on average. As the years progress, greenhouse gas emissions increase, and it has negative consequences for nature, such as global warming. Energy production is the main cause of carbon emissions. Firms engaged in energy production resort to fossil fuels at the rate of 87% to provide the energy they need. It is known that solid, liquid, and gaseous fuels also cause different levels of carbon dioxide emissions. According to the greenhouse gas inventory, it was 132.5 million tons in 1990, and the figure increased to 340 million tons in 2014. In other words, the carbon emissions of the energy sector increased by 156% between 1990 and 2014. To reduce this carbon dioxide emissions, renewable energy source should be used. Today, there are studies in many countries that have started to ban diesel and gasoline vehicles. To use of fully electric vehicles instead of these vehicles is encouraged. It is thought that electric vehicles can significantly reduce carbon dioxide emissions, unlike diesel and gasoline cars. When switching to electric vehicles technology, the question arises from where the need energy will be met. It is thought that when the number of solar panels, wind power plants, and hydroelectric power plants is increased, most of the energy needed can be met. For this reason, energy production from fossil fuels must be limited in order to prevent negative factors such as global warming and seasonal changes. In our study, by considering the role of solid, liquid, and gaseous fuels in carbon dioxide emissions amounts, the data were analyzed with time series and FP-profit model, and a future production was made a result of this analysis. Carbon dioxide emissions data for Turkey is taken from https data.worldbank.org. The received data was transferred to Python software, and the column matrix was created as date and emissions data. The index data was added to this column matrix with the help of Python software. A fit model was created with the FP-profit model for this defined matrix. Period and frame value are defined in the model for the future forecast. The period was repeated as 34 years, and predictive value was found until 2050. In order to test the accuracy of the model, the entire model was defined as training data, and the model predicted for the years whose carbon dioxide emissions value was known. Carbon dioxide emissions data for the next 34 years were also predicted using time series. The FP-profit model made by open source by Facebook predicts the future with time series analysis. FP-profit uses time as a regressor and treats the fit several linear and non-linear functions of time as components. Total carbon dioxide emissions for Turkey are defined, and the future forecast is made with the FP-profit model in Python. Total carbon dioxide emissions are given in table 1. Estimated future carbon dioxide emissions values with the FP-profit model is given in table 2. Carbon dioxide emissions estimation data are shown graphically in Fig 1, and trend analysis is shown in Fig 2. Trend analysis. Emission values from solid fuels are shown in table 3. Carbon dioxide emissions from solid fuel consumption, FP-profit outputs are shown in table 4. Carbon dioxide emissions from solid fuel estimation data are shown graphically in Fig 3, and trend analysis is shown in Fig 4. Emission values from liquid fuels are shown in table 5. Carbon dioxide emissions from liquid fuel consumption, FP-profit outputs are shown in table 6. Carbon dioxide emissions from liquid fuel estimation data shown graphically in Fig 5, and trend analysis is shown in Fig 6. Emission values from gaseous fuels are shown in table 7. Carbon dioxide emissions from gaseous fuel consumption, FP-profit outputs are shown in table 8. Carbon dioxide emissions from gaseous fuels estimation data are shown graphically in Fig 7, and trend analysis is shown in Fig 8. The International Energy Agency has made a statement that demand for fossil fuels will increase until 2050, and 130% increase in carbon emissions values will be observed accordingly. The carbon emissions in 2016 is 372,724.881 in our study. It was estimated that carbon emissions in Turkey could increase by 94% until 2050. It is estimated that the carbon dioxide emissions of solid fuels will increase by nearly 13%. That of liquid fuels will decrease by nearly 57%, and that of gaseous fuels will increase by nearly 156%. When the trend analyses are examined, it is seen that the increase of carbon dioxide emissions values are more in the autumn and winter transition months. This increase is likely due to residents' heating needs. The conservation of liquid fuels of carbon dioxide emissions will decrease with the transition to electric vehicles. The increase in the contribution of gaseous fuels to carbon dioxide emissions is due to the widespread of use of natural gas. Therefore, alternative energy sources such as solar energy and hydroelectric power plants should be directed. Continuing to use fossil fuels for needs such as warming and energy production will aggravate global warming and seasonal changes. Using renewable energy sources in energy production allows us to leave a more livable world to future generations. Therefore, renewable energy sources such as water, wind, and solar energy should gradually replace fossil fuels. Thank you so much. My presentation is over here. Also, a pre-profit model was used for the first time in Turkey in this study. Thank you.
Okay, thank you very much. I mean, it was a very interesting presentation, actually. I have some questions, but first of all, I would like to read the question of Vahdettin Demir, whether, I don't know whether you can see it, but could you tell us which method or test was used in trend analysis and in what confidence interval?
I don't understand. Repeat after me, please.
Okay, so
Pardon.
you
Repeat, please.
have presented some trend analysis. So
Evet.
what is the
Okay. Time series analysis. Time series. A pre-profit model is the a pre-profit model made by Facebook and a pre-profit model using time series analysis and trend analysis years by years.
Okay, so did you check whether the results are in the confidence interval, or did you have made some tests regarding this?
Repeat this. Sorry.
For the trend analysis, I mean, for sensitivity, for achieving the accurate results, you should. I mean, it's advised that you apply some tests. One of them is the confidence interval. I mean, what is
yes, I made in Python software a pre-profit model test.
Maybe, I mean, I think it's we can move to the second question. I mean, maybe Vahdettin Demir and other interested participants could read the manuscript and turn you back if they couldn't find the necessary information. Huh? So my question is, I think it's very interesting because it shows like a very big company like Facebook is also interested in such activities. I would suggest to maybe to compare this results with a more sophisticated methodology, and then maybe to conduct some local measurements of CO2, because these data is also available, or it could be calculated. Especially in big cities, you have these emission values. So you could feed the model with this local data, and then maybe to fit better, I mean, you can better fit into the confidence interval. So this is, I will connect it to the
okay. Planning maybe fuzzy logic and artificial neural network next time, for the next time.
So, but maybe you should also check the data sources which are available. For example, you could use Earth Engine, Google Earth Engine. You could use local databases. You could estimate CO2 emissions from land use, land cover. I mean, this is a huge subject, which is very interesting. Okay, thank you very much.
Thank you.
Any questions?
I have a question, personal one. By the way, I am checking whether there is any question in YouTube and Zoom, but since then there is no one. But I would like to ask a question about your open source code. Do you share your models code on GitHub or any other place?
Okay. Yani
A
kod
GitHub page where we can see your models code, Python code, I mean.
in Ubuntu now Windows in
No,
Ubuntu
That is
Linux.
operating system. I mean the Python code.
Yes, I have.
Okay.
But the code is in Ubuntu Linux.
Okay, will you share the code in GitHub repository?
Tabii. Okay, tabii.
Okay, thank you.
Sure,
I'm looking
sure.
forward to it because the code is important. If you assign a model in the literature, especially with the Python code, it should be an open source code. Therefore, it would be better if you share it on on GitHub environment. I recommend you this. Thank you. There is no other questions, Professor, so we can skip to the next presentation.
Okay, so thank you very much.
Thank you.
So it was a very fruitful discussion as well. So the next presenters are from the Mersin University, Bilal Özay and Osman Orhan. The title is using artificial analytical hierarchy process for float suspectability mapping of Mersin, Turkey. So the floor is yours. Maybe you just want to briefly introduce yourself. I think Bilal Özay is going to present it.
I am Bilal Özay, and our study is flood susceptibility mapping of Mersin with analytical hierarchy process. And Mersin is a city in Turkey, and our susceptibility mapping is the first susceptibility map for Mersin. And we will see the results in our presentation, which factors we used and what are the results. In our presentation, our content is, first I will explain disasters and floods, and then I will continue with our study area and why we choose this area and why we choose this topic. And then I will explain the condition factors and how did we use analytic hierarchy process, and then we will see the results. These two tables are showing us.
Excuse me, your screen is not moving. Could you make your presentation on full screen?
It was on full screen, but
no. Okay, we are seeing the tables now. I mean, so
okay.
It's good. It's good.
Can you see it right now?
Yes, we are seeing the slides saying disaster/flood and some with tables.
Okay.
But then it will be
on the right side we see.
Just a second. If it would be better if you make it full screen, because we are also seeing your notes, and then we are seeing the forthcoming slides. To make it full slides, I mean, there is on the right hand side, right? So somewhere here, I cannot see it right now. But okay, so
right now.
Okay, so continue. Okay.
I mean.
So you have to push. Okay.
On the right side, we.
Okay.
Is it okay? Okay. On the right side, we see the deaths caused by disasters in the world, and we can see that the flood is in top 3. And on the left side, we have the type of disasters and number of events on the world. And again, flood is important for us because it is on top 3 by number of events. So in Mersin, like when we look at the Mersin, This is our study area. The red line shows our study area.
Sorry, Bilal. We are not seeing the study area, so you have to switch to the presentation mode. In PowerPoint.
Right now?
Yes, we are seeing it now.
Okay. On the left side, we see the Mersin. The red line shows our study area, and on the right side, we have some examples of floods in Mersin. The right top side is it was in highway. As you can see, like it looks like a river, but it's not. It was a highway. On the bottom side, we see the shoreline of Mersin, like it's under the effect of flood, and these are central locations of Mersin. And when we look at the Mersin, we can obviously see the riverbeds, and they are all like everywhere. And the city, the built-up area of Mersin is located in right next to these rivers or over them. Most of the built-up area in Mersin is built by drying these rivers. So the reason of
Sorry, I think we are still not seeing what the slide that you are talking about. Sam, can you move the next slide?
Mr. Özay, can you press just F5 button in order to have your presentation on full screen? Because we are not using double screens. So when you use your technical notes, your presentation is not seen properly. So just press the F5 button and let's go on.
Right now? Can you see it?
No, it's so when next to this, on the right-hand side and the bottom, there is the zoom. And then next to that, there is a kind of a presentation sign, or you can press F5, but it has this one. Press that.
Okay, I did it. But I don't know why you see my notes.
Those probably you are using to slide, but then you have to move synchronously with the slide that you are talking about. Otherwise, we cannot understand it. Okay.
So Mersin is affected by flood every year. Due to its devastating effect, it's required to take measures. For this purpose, it's required to prepare a susceptibility map, and susceptibility map will show the areas under risk of floods. When adequate measures are taken in flood-sensitive areas, it's possible to greatly reduce effects of floods. For the study, we used analytic hierarchy process, and we decided to choose 10 factors in our project. And these 10 factors are elevation, slope, distance to river, distance to drainage, drainage density, land cover, TVI, SPI, aspect, and curvature. So we prepared these maps in GIS environment, and they have 30-meter pixel size. And our top two factors are elevation and slope. In elevation, we separated elevation into 6 groups, and the elevation is important because the lower points of elevation will attract and will accumulate water in these areas. So the lower the elevation, higher risk is generated for floods. In slope, the slope is another important factor for us because the lower slope means that water will accumulate in those locations. So as slope gets lower, the risk for flood will increase. Distance to river and distance to drainage maps, and the rivers are natural paths for water, so they are also important. And the drainage map is important because they are like underground paths for floods. So these two factors are also important for us. Closer locations to these two factors means higher risk for floods. And we have drainage density analysis map, and here, the distance to drainage is important, but also the density of these drainage lines are important for us. If it is dense, it means high risk for flood. In land cover analysis map, we separated.
Maybe you can move the slides a little bit, because I think we are almost in the 8th slide, slide 8. So we are seeing, yeah, okay.
I don't know the problem is, but
Okay, now it's, I mean, we are seeing it a little bit more, the products that you produced. Okay.
okay. In land cover analysis map, we have separated them into 5 groups. We have agricultural areas, artificial surfaces, and these are 2 important factors for us because, like, when we look at these areas, the artificial surfaces are the mainly built-up areas of Mersin, and they are mostly located on surrounding of the river bases, and agricultural areas are the same. And the most dangerous, like highest risk for us, is the water bodies and wetlands and artificial surfaces. They are the top 3 ones. And we have next TVI and SPI analysis. We used slope and distance. We used slope and river factors to create these TVI and SPI maps. Higher TVI means higher risk for us, and lower SPI means higher risk for us. And we have aspect analysis and curvature analysis. In aspect, usually there are 9 groups, like 8 directions and flat surfaces, but mostly in flat analysis, they group them as 4 because these directions are like they have similar characteristics, so we can like group them at 1. And since aspect is a like in as weight, it has a low weight, so it's better if we group them as 4 instead of 9. In curvature, we have 3 groups. The red ones are red one and blue ones are shows curves, and -1 between -1 and 1 is showing us flat surfaces. So flat surface is the highest risk area for us in our study, and these are our factor weights and class weights. And as I said, elevation is the highest. Elevation slope is the highest factors for us. They are mostly important. And in every factor, we have class weights, which represents the pixel values. And all pixels have like their special values. So when we calculate them we achieve the final susceptibility map for Mersin. And as we can see, on the east side, we have very high and high risk areas on the shoreline, which was the built-up area of Mersin. So and when we look at the results, the study area Mersin is a coastal zone with a low elevation, and most of the built-up areas of districts were constructed over river zones by drying them. The especially high populated districts like such as Akdeniz, Mezitli, Toroslar, and Yenişehir. And when we look at the numbers, the 90% of population of Mersin is affected by the floods every year. Built-up area of districts are close locations to riverbeds. Anamur, Bozcaada'sı, like Aydıncık and other districts are under risk of flood. The elevation, distance to river, and drainage density are important factors for flood and flood susceptibility mapping. Thus, high risk within these conditioning factors creates greater risk for flood. And when we look at this susceptibility map, the 70% of population is living in high and very high risk areas. And this was my presentation. Thank you.
Okay, thank you very much. I mean, it was at the end, it was a good presentation. I mean, we understood the context. So there is one question. I have also some questions, but there is one question saying, which types of reclassification method did you apply to divide the final flood suspectability map? So,
Can you ask the question again?
Which types of risk classification methods did you apply to divide the final flood suspectability map?
I mean, we used pixel size. We calculated them as like area pixel size. We
Okay, so maybe so you could elaborate on how you give the weights to the in an analytical hierarchy process. You are giving weights. So did you make literature review regarding the weights, or did you ask the policymakers? How did you handle this difficult question of weights in analytical hierarchy process?
we made a literature research, and after that we asked for, like, I mean, in literature, yes, there are different areas that we considered as like example for us, but it was important for us to ask someone who has idea about Mersin. So we have experts on meteorology in Mersin, and a couple of experts in Mersin University. They are engineers.
You made a survey regarding that? How did you collect for criteria in analytical hierarchy process, you are giving weights. So how did you collect the feedback from experts? Did you generate a survey regarding that?
No, we asked them like directly, like how we should approach these data, like the class weights, like is it right to do this?
But maybe it's more structured approaches could be applied next time, okay? And then maybe it's you could be better. It's if you apply sensitivity analysis. I mean, because the Mersin area is very crucial with respect to Turkey, because according to the sea level rise projections, Mersin is going to be flooded according to the climate change models, especially the mortality.
Right now we are working on machine learning, while we are using machine learning for flood susceptibility map, and we have like inventory map for Mersin. We have more than like 400 locations for floods, and we used this inventory map to see if this is the right map, but we didn't put this on our presentation. Like it was later, it was something that we did later, but these 400 locations were mostly on high and very high risk zones.
Okay, so it's they're very valuable. Okay, thank you very much. By the way, I am seeing Mehmet Emin Tabar. Mr. Tabar shared his codes, Python codes in GitHub, which is very useful, I think, for further development. So I'm moving to the next presentation. It is from Nigeria. The title is Analyzing Influence of Abandoned Mining Sites of Land Use Land Cover and the Terrain in Jos, Nigeria. The presenters are Adamu Bala, Ahmadu Bello, and I think and then Tai Olubafemi Adewoyi, Abdulaziz Aliyu Onoto, if I pronounce this correctly. So welcome. I can see Mr. Bala, but
Hello.
Hi, how are you? Welcome.
Fine. Thank you. And
so we are very excited, and we are happy to have you here. So please share the share your presentation and share your study.
okay. My name is Adamu Bala. I'm here to present a paper on behalf of the other authors, Prof. Adewi, Dr. Samuel Garba, and Abdulaziz Onotu, analyzing the influence of abandoned mining sites on land use, land cover, and terrain in Jos, Nigeria. These are the presentation outlines. For the introduction, mining activities has been going on in Jos South and for more than a century ago. And most of the mining minerals are columbite, casterite, and tin. Related researches have been carried out in the study area. As you can see, list of researchers that have carried out related researches. This is the study area. Nigeria is here, then the Plateau State and the study area, which is just South local government area. These are some of the abandoned mining sites. Plate 1 is indicating active mining activities. You can see gully erosion going on. And plate B is indicating approach of the mining site to the settlements. And for the plate C is showing partially reclaimed area. These are the methodology for the research, which are in 3 phases. The phase 1 is this spot 5 are Landsat 8 images, merging, then followed by supervised classification. Then phase B deals with the vector shape file of the land degraded sites, which are the mining sites anyway, which are obtained from Bala 2018. Then the third phase is the SRTM data obtained from USGS website. These are the data set that were utilized. You can see spot 5, which is 2.5 meter resolution Landsat 8, DEM data, vector files, and the degraded sites. These are the classes that were carried out in the study area. You can see mine fonts, which is the abandoned mine site, settlements, bare rock, farmlands, and land and vegetation. In this, and this patch is showing the SRTM data which were used to analyze the terrain within the study area. From the results, there were overall accuracy of 77.82 and 73.16 for the kappa coefficient and the overall accuracy. You can see the classes of the land use land cover, which with a total area of 512 kilometers square. Mine fonts occupy and bare lands occupy 9.2%. Moving on, this result, which is figure 4, is showing the relationship between the settlements and the degraded sites, which are the mining fonts. You can see that the mine fonts, which are in blue color, are spread throughout the area, and the settlements are shown in red color. The area is normally rocky area with a lot of crops, rock outcrops within the area. And this one is showing the relationship between the bare land and the mine fonts, which are the abandoned mine sites, because they are seasonally inundated. And this one is showing the relationship between the rock outcrops and the mine fonts, or the abandoned mine sites anyway. The area is rocky area, that's why it covers 41.56% in the study area. And this figure is showing, which is figure 7, is showing the relationship between the vegetation, farmland, and the abandoned mine sites. And the last figure shows the settlements and the abandoned mine sites. You can see that the abandoned mine sites are distributed indiscriminately within the settlements. This is because most of the mine fonts or abandoned mine sites occurred as a result of mining activities. And one of the major factors in carrying out mining is the area where the minerals are located, which are irrespective of any position. It can occur in the lower land or upper part of the settlements. This is the analysis of the terrain in the neighborhood of the degraded sites. You can see the slope from the higher to the lower. The highest elevation is 1,512 meters above mean sea level, and the lowest you can see is 11%. As you can see, the degraded sites are spread at the higher land and lower lands. So it doesn't matter whether it is a low land or higher land, because this is because the factors in locating the mining sites is the availability of minerals within the area, which can be either at the lower part of the elevation or at the higher part of the elevation. This is the analysis of the slope. You can see from the map, the abandoned mine sites are overlaid on the slope map from 0 to 0.99. As you can see, the mine fonts are also irrespective of the slope within the area. It can occur whether at the lower land or upper land. But if looking at the map, you can see that in most cases, the settlements, the abandoned mine sites are overlaid mostly in the slopy area that is within 0%, because, and this further proves that most of the mining sites are seasonally inundated because the slope is not that much. Then this one is indicating the relationship between the contours and the abandoned mine sites. As you can see from figure 11, the spatial location of the site is irrespective of the contour values, as some sites are located on a steep slope, while others are on a gentle slope. And this one is showing the relationship between flow accumulation and the abandoned mine sites. Again, it is observed that most of the stream networks were connected with the degraded site, which proves that the fact that most of the degraded sites are seasonally inundated. That's with the water. The high elevation of the area, this is because whenever it rains, there is normally overflow of water from the high elevation to the lower land. And on the process of the running water, it also carries some materials downward, which leads to erosion and subsequently to degradation. In addition to elevation, slopes that were affected by degradation were identified because mountain surfaces inherently have steep slopes. Also, most of the degraded sites occur as a result of mining activities. The major condition or criteria for mining minerals is its availability. Hence, mining activities can be done whether at lower land or upper land. The study revealed that the spatial location of the degraded site is irrespective of the terrain of the area. And there are certain appropriate land use land cover in the neighborhood of the study area that can be utilized. For example, I made mention that the mining ponds are seasonally inundated. So block industries and water treatment and fish farming can be sited within some of these abandoned mine sites so that it can be utilized positively. The authors would like to acknowledge the contribution of the Office of the Surveyor General of the Federation, Abuja, Nigeria, for providing us with the Spot 5 satellite images, and the United States Geological Survey Agency for providing us with the Landsat satellite images. Thank you for listening.
Okay, thank you very much. It was a very fruitful, on-time presentation. I have some questions, but I would like to leave the floor to one maybe question from chat, or maybe Mr. Iban has a question. I don't know.
I don't have, but there is no question so far in the chat session. You can ask.
Then I will ask my question. So I think it's a very important subject, and it is. I mean, we are also coming across with that in Turkey as well, about this abandoned mine sites, and then the nature, of course, tries to take back what they has given. One question. I mean, I have several questions, but first of all, I think it will be more emphasized if you do a time series analysis, like land use change detection. So before the mine, when the mine is there, and after the mine. So then it will be more drastic to show it to scientific community or some policymakers.
Okay.
And then, so you use SRTM in a very rocky area.
Yes.
Do you have any other heights information sources in Nigeria? Maybe, I don't know, you could have a test field with drones, or how would you please elaborate on it a little bit?
We have first order control points that were established by the Office of the Surveyor General of the Federation, which are spread within most of the rural areas, urban areas anyway in the country, which can serve as a control points for verification of the SRTM data.
Yeah. But you know, SRTM is like in height, it's almost like in like decimeters accuracy. If it's a rocky area, which means there is sharp height differences. So maybe it doesn't that much differ in showing the results of degradation, but it could have an impact on the total area degraded.
Yeah, I agree with you, but some of the mine sites, as you can see, plate one, some of them are as deep as 50 meters down below the earth surface. And I think the SRTM is 30 meters. So for places like this one, I think it should be able to give some idea, even though it may not be as accurate as it should be. But for the purpose of the research, which is mainly to show how the relationship between the terrain and the abandoned mine sites within the study area. So I think subsequent research are going to utilize a better option, maybe through field verification and maybe obtaining other source of data from the topographic maps through digitization and other processes.
Yeah, I think it's I absolutely agree. But I mean, you could also check some other sources like the European Commission or Google Earth Engine. Maybe they are providing some other height information that you could compare the results, check whether it makes a difference to use a more accurate data. Because in
Okay,
Europe,
I have.
there is a
Yeah,
more
go
accurate
ahead.
Copernicus.
Okay. One of the major constraints of the research, or let me say, one of the major issues with most of the researches in Africa is the source of data. If you look at it, some of the data are not free of charge, and the cost of acquisition of the data may be difficult in some cases.
Yeah.
That's why we have to utilize the data that is available for the research. But all the comments are noted, and subsequent researches are going to take care of the comments.
Yeah, I think it's perfect. So good luck, and I think it's a very interesting study. So thank you very much.
Okay, thank you.
We haven't received any questions from the audience, Professor.
Okay, so then we will move to another interesting study: two-dimensional flood modeling with the help of GIS. From Vahdettin Demir, Aytekin Alptekin, Mehmet Özgür Çelik, and Murat Yakar. So welcome. I think Vahdettin Demir is going to present it. Welcome, Mr. Demir. Your microphone is muted. Okay.
Now it's working?
Yes.
Thank you. First of all, my name is Vahdettin Demir. We prepared this study with my supervisor, Murat Yakar, and my college PhD student, Aydın Alptekin and Özgür Çelik. Our title, 2D flood modeling with help of GIS for Mersin Lamas River. Now it is working.
Yes, it's working now.
At the content, we use classical content, introduction, study area, and method. We work Mersin Lamas River and HECRAS 2D model. Application result, discussion, and conclusion. We say first, full floods are the second in the world in terms of loss of life and property, and the first among meteorological disasters. And this figure shows flood number of Turkey. And then to reduce this damage of flood affecting our lives, it's necessary to know the mechanism that turns flood into a disaster and to take precaution before the flood occurs. And our study area, Lamas River, was chosen as study area, and 2D flood modeling was performed with Geographical Information System and HECRAS program. As a result of the modeling, flood depth propagation maps were obtained different flood return periods. And our study area, Mersin, is located near to Adana, Karaman, Niğde, Konya, and Antalya district. The surface of Mersin province is about 15,000 kilometers square, and except for 50% of Tarsus district, all of it's within the boundary of Eastern Mediterranean basin. And we can see at the right figure, Mersin boundary and Eastern Mediterranean basin, our study area, and Lamas River Station and River Line. And also we can say Lamas River or Limon River is located in the Erdem district. This river takes its source from the Yörük mountain in the region of Karaydın. Its length is 99 kilometers. The annual average flow rate is 6.25 cubic meter per second. And our study, we use digital elevation model. The resolution of this dam is 10 meters. And Manning friction coefficient were taken 0.04 as average value in the study. This is very important parameter for flood modeling. This is a flood and friction value. And we use HECRAS program, can model 2D flow and developed by United States Army Corporation and engineers. HECRAS model modeling using 2D Sam-Venant equation and 2D flow diffusion wave equation. And we can see this equation 1, 2, 3. And one dimensional and two dimensional modeling area is shown the figure left. We can say if you want to just cross-section area for flood modeling, for example, bridge is enough or not, you can use 1D modeling. But if you want the area modeling, for example, effective area, you can use 2D modeling. And the application, we use return periods. We take this data from flood management plan for Mersin. Of course, we can calculate with statistical and stochastic model, but first of all, we take this management plan for compare the result. And Manning values, I say, digital elevation model, and we use GIS and basin tool. For example, we can see our dam and accumulation map, river line, border line, like this. Flood modeling was carried out in the HECRAS study, we say, but using 25 meters calculation area. We say this area a mesh area. The distribution of return periods is given the table. For example, Q50, Q100, and Q500, and areas, effective areas, these areas. Also, the maps of floods are shown in the figure for different return period. When we see the figures, upstream area is good, not risky any flood, but downstream area is effective a lot of area. We can say upstream area is research of water coming from the Mediterranean Sea. We say this area downstream area. And when figure is examined, it's seen that flow rate within the 50 years are overflowing from the riverbed or cross section, not enough this area, especially towards the downstream part of the study are inundated. Now we can see downstream area, many greenhouse building areas are effective this flood modeling. At the conclusion, in the study, we used 3 different return periods, modeled with HECRAS 2D program, and digital elevation model or high model was obtained General Directorate of State Hydraulic Works, we say DSAE, and I want to say thanks. Return periods take from basin management plan, and Manning friction coefficient was defined on the 25 meters mesh. All data export the ArcGIS program and prepare the flood propagation maps. As a result of the modeling, Lamas River effective Q50 flow rate significantly affected by floods. And at this region, regulation that can carry at least Q100 flood flow rates should be made in the another of these urban areas. And we can see the result at the downstream area have a 1.5 meters water high, and this area is very effective, this modeling. Also, cross section is not enough this area. And when we see the modeling, at the downstream area have a pooling area, Mersin and Antalya highway region especially. Can you reduce this pooling situation? New canal can open on this route. And thank you for listening to me.
Okay, thank you very much. It was a very interesting presentation. We could take some questions from the audience or from chat.
We haven't received so far.
Okay, so then I have to ask some questions,
Yes, please.
Mr. Demir. So thank you very much. So I think so maybe you can elaborate on this Q50. I think it's an event happening on every 50 years. But don't we have events, float events in this plan happening in every year or 10 years? I think that you should also have that information. Why you begin with an event happening in 50 years, Q50.
General reports are using this return periods. Of course, we can use, for example, 10 years or 20 years, but problem is big in the 50 years periods.
Yeah,
And
because the 50 years has a more
yeah,
drastic accumulation. But
yes,
I think due to the climate change and we will see more frequent floods in Turkey. So this 50 years period will be more, we will see them in every 20 years, for example. And then I did some flood studies, and then we were in European Commission when I was working. We were looking also at the 10 years period. So I would suggest to check if they have it to check the 10 years period as well.
of course, we can use, for example, different return period at the study area. General regulations important for us at the study. When we check also another return period, but general at the report we see at the literature also, these return periods generally use, so we are use.
Okay. So another thing maybe, I mean, it's the model is very robust and solid, the SECRAS two-dimensional model. But did you compare the model results with our, for example, if you have a three-dimensional
Yes, yes, of course.
study area and then you float some areas, what is the ratio? I mean, what is the disparity? Are they approaching to each other, or there's big disparities between each?
Yes, of course, calibration very important for this study. Calibration can be use another program, but this study we use just one program to see the area, just approximately where is effective this area. But next study we will use, for example, Flow 2D program. This program is very near the result with HECRAS program.
Yeah.
Yes, of course, but now just we use one program at the conference.
Okay, so it's still interesting, and then it's maybe, I mean, as a geomatics engineer, our contribution is to deliver some fine tunings in calibration or fine tunings in 3 dimension or in 2 dimension as well. Okay, thank you very much.
Thank you.
So let's move to another I think that the session is very interesting. So we will move to the last, no, okay. So we will move to a
So
fifth.
shall I interrupt for a while? Because we have discovered the reason why the presentation problem existed in the previous one. And I would like to remind all participants to share all screen rather than sharing just one software. So if you select PowerPoint for sharing your screen, the Zoom can have some problems for swiping your slides. So therefore, it is important to share your whole screen rather than sharing the software. Thank you.
Okay. So, I mean, I would like to invite İldeniz Leyla Öztürk to present using modern methods to determine the suitable area for rain harvesting. So, floor is yours.
Hello.
You're muted. Yes, we can hear you, maybe. Yeah.
1 minute. I can start.
Yes. We can see your screen as well. Please share your screen.
Okay.
Okay.
Hello.
Yes, please proceed.
Good afternoon, everyone. Thank you for joining us today, and welcome to today's webinar. My name is İldeniz Zeyla Öztürk. I am a master student at Remote Sizing and Geographical Information Systems Master Programming at Mersin University. Today I am talking about my thesis subject. My data collection work continues. So today I will give information rainwater harvesting methods and using datasets briefly. Using modern methods to determine the suitable area for rain harvesting. Outline, the subject can be looked at under the following headings. Firstly, introduction, secondly, material and methods, and finally, conclusion. And at the same time, flights will be made with UAV. Introduction. Water is the most important and basic life source of all living organisms living in the ecological system on Earth. Throughout history, the birth and development regions of many civilizations have been on the waterfront. Proximity to water resources has maintained its importance from past to present and has had a direct impact on the development of societies. The raw and unconscious use of water harms the country's natural resources. Due to the unconscious use of water in the thousands of acres of land in the world, agriculture has become impossible and yield losses have occurred. The advantage of the rain harvesting method are that it is simple and economical, and the water transmission losses are low. In the water harvesting method, water collection areas are roofs, courtyards, streets, and squares, small soil surface, sloping areas, and large basins that feed seasonal flows. The water storage medium is divided into underground storage and storage on the soil surface. While soil sediments and cisterns are used for underground storage, tanks, reservoir, and pools are used as storage media on the soil surface. The rain harvesting system is limited and prone to limited rainfall. Therefore, limited precipitation is among the main limiting factors on the method. Hello, can I speak Turkish?
No.
Okay.
So please, I mean,
but I am a pro. Benim bir problemim var da kameram açılmadı.
Okay, so I mean, fine. You can continue. We are seeing your presentation.
Okay, thank you.
So we can see your slides.
Okay. Material and method. When previous studies on the subject are examined, it is seen that biophysical and socioeconomic factors are preferred. RWH, biophysical factors are rainfall, land use, slope, aspect, soil type, soil depth, and drainage intensity were selected to assess potential RWH sites. Socioeconomic factors were used to identify unsuitable areas. These factors are distance to farmland, roads, urban areas, wells, falls, and drainage networks. Study aim. My thesis study area is Karacılı village. Agriculture is an important economic resources in the village of Karacılı. Rain harvesting tools are also preferred. Data collection and pre-processing. As in other studies, I choose to work with biophysical and socioeconomic factors for my thesis. The sources of the main factors that will be used to determine suitable sites for our WH are shown in table 1. Raw data will come from various government agencies, files study. Monthly precipitation data will be collected from the meteorology unit. Annual average precipitation will be calculated for each station. Maps will be created in ArcGIS environment using 5-meter dam data and 3D analysis tool. Soil map and drainage density map of the study area will be created according to slope, aspect, rainfall, soil infiltration, feature, and error. In addition, thematic layers such as existing water areas will be prepared using ArcGIS software. Analytic hierarchy process. AHP method will be used to generate the potential RWH map. AHP is a method used to analyze and organize complex decisions based on professional knowledge by consulting experts on the importance of selection criteria for rain harvesting using a scala from 1 to 9. Layer selection. The criteria to be used in this study, precipitation criteria, slope, aspect, soil type, soil depth, drainage density, land use, cover. Precipitation, the most influence factor for the higher RWH potential is precipitation. Average annual precipitation data is one of the prerequisites for large scala RWH structures. More rainfall in an area results in higher RWH potential. Higher precipitation volume indicates higher water volume and higher potential flow, and consequently higher potential for local flow capture using RWH structure. Slope, soil type, soil depth, land use, drainage density, socioeconomic criteria. Both biophysical and socioeconomic criteria need to consider to ensure the success of RWH techniques and facilitate the adoption of new RWH technology by local farms. Choosing appropriate socioeconomic parameters is critical to achieve desired results. RWH structure can't be applied in drainage networks for environmental, technique, and financial reasons. The aspect table distance from the roads should be considered to avoid any possibility of future conflict between the road development and the considered structures. It is very important to exclude urban areas from being selected as RWH sites for safe reasons. In addition, agricultural lands are both economically and environmentally valuable resources and should be excluded simply because they can't be disturbed by water collection systems, but proximity to rainwater harvesting systems can be an advantage if appropriate safety measures and maintained. Conclusion. Rainwater harvesting is becoming one of the most promising alternative freshwater resources that can potentially be captured and used, especially in arid and semi-arid regions. This study is the preliminary information of the system to be established, and its analysis are ongoing. Using the biophysical and socioeconomic factors, the appropriate methods, and it will be determined whether the existing areas are suitable or not. In addition, this working method will be tested with the AHP method in addition to the methods. Thank you.
Okay, thank you very much.
Thank you.
We totally understood the presentation, no worries. So any questions from the audience?
We haven't received so far.
Okay, so I mean, I think it's an interesting subject, in my opinion, and maybe it could be a good big project as well in the future. So since it includes some investments in infrastructures, I would suggest the authors to try to incorporate the climate model precipitation values for the forthcoming years. And this will be very interesting then, because since I'm going to invest on this rain harvesting, it will be better and it will be very useful to know what will the precipitation values, how they change in the future. So as a recommendation. So I would like to move to the last presentation of this session. Analysis of carbon absorption amount of urban forests by special interpretation methods from İzmir Katip Çelebi, from Elif Akyel and Fatih Kenar. I think Elif Akyel is here. So welcome.
Welcome everyone, good afternoon. I'm Elif Akyel from Katip Çelebi University, Department of Geometric Engineering. I will talk about carbon absorption of urban forests. Full screen.
Yeah, please share it as a full screen. Yes, that one, yes.
Okay.
Yeah. Just a second. Click it.
Okay.
Okay.
My title is Analysis of Carbon Absorption Amount of Urban Forests by Spatial Interpolation Methods. Introduction. It can be said that the concept of urban forests has emerged as a natural result of increasing urbanization both in the world and in our country. The concept of urban forests, which provides the opportunity to offer the social functions of forested people, gains importance day by day. The urban forest project started to implement it in our country in 2003. With this project, a total of 64 forests have been established in 55 provinces and 9 districts until the end of 2008. The oxygen produced, the carbon dioxide consumed, and the carbon absorption of 64 forests that constitute the analysis area of this study were calculated. As a result of interpolation studies carried out in Geographic Information System, maps showing the contribution of urban forests to the environment were created and all these factors were analyzed on a spatial basis. Data obtained from the Forest Regional Directorate were used in the study. Assessment of the contribution of 64 urban forests to the environment established by the ministry constitutes the purpose of the study. In this context, the oxygen produced by the forest, the carbon dioxide consumed, and the carbon absorption amount maps were created. The average carbon absorption amount of urban forests was calculated as 643.93 tons. These maps shows the distribution of Turkey urban forests on the basis of Forest Regional Directorate. There are 28 regional directorate of forests in Turkey. Method. In this section, I will talk about the method used in the study. In the study, the carbon dioxide consumed by urban forests, the corresponding carbon emission and the amount of oxygen produced were visualized in the GIS. Image distance technique, which allows analysis on spatial basis, was used in creation of maps. Maps produced with this technique reveal the contribution of urban forests across the country to the environment. In addition, as a result of the analysis made using the data of the existing forests, the amount of oxygen produced by the areas near the forest, the rate of carbon dioxide consumption, and the amount of carbon emission can be estimated. Use technique, IDV technique, IDV interpolation method was used in this study. IDV is a complete intermediate value generator such that it consolidates values of data. Results and discussion. IDV interpolation method was used to determine the spatial models of variance that emerge in the contribution of urban forests to the environment. Maps were obtained that reveal the created models effectively. On the maps, oxygen production and carbon dioxide consumption, which are factors affecting carbon emission, are visualized by interpolating with GIS. Oxygen production map of urban forests. The map contains the oxygen production map of urban forests. When the map is examined, it can be said that the amount of oxygen production is high, especially in the southwestern part of the country. In the inner and eastern parts of the country, the amount of oxygen produced by urban forests is lower than other regions. On the other hand, Erzurum urban forest, which is established on an area of 717 hectares, stands out in that region with 600 tons of oxygen production. Antalya urban forest is the forest with the highest contribution to the ecosystem with 8,367 tons of oxygen production. On the other hand, Yenice urban forest located in Karabük with 0.81 was the forest with the lowest oxygen production. Carbon dioxide map of urban forest. This map showing the carbon dioxide consumption of urban forests. When the map is interpreted, it can be said that the marine urban forests in the southwestern part provide a higher rate of carbon dioxide consumption. The urban forest with the highest carbon dioxide consumption is the Antalya urban forest with 55,000 tons of consumption. The least consumption amount was Karabük-Yenice urban forest with 6 tons. The situation is similar to the oxygen production map. The insufficiency of urban forests in the eastern parts of country can also be observed in the carbon dioxide consumption rate map. Carbon absorption map of urban forests. The carbon absorption amounts of the urban forests are given in the map. The situation is similar to the oxygen production and carbon dioxide consumption maps. The map was created to show oxygen production, carbon dioxide consumption, and carbon absorption together on the basis Forest Regional Directorate. Urban forests have many contributions to the environment. Forests that increase oxygen production help to maintain carbon balance by reducing carbon dioxide consumption. The total oxygen production of urban forests, which have an average oxygen production of 359 tons. Evaluated within the scope of the study is 21,158 tons. Forests whose total carbon dioxide consumption was 55,000 tons. The average consumption amount was determined as 148.79. In forests where a total of 41,148 tons of carbon is stored, an average of 642.93. The forest with the highest amount of carbon storage was the Antalya urban forest. 15,000 tons of carbon is stored in this forest. The lowest absorption amount among urban forests was determined as Yeni urban forest in Karabük with 2 tons. Reasons such as population growth and the use of fossil fuels cause an increase in greenhouse gas consisting of carbon dioxide, methane, and ozone. The main reason for global warming is this gas released into the atmosphere. By regulating the carbon balance of forests in the city atmosphere, it makes it possible to slow down global warming. 64 urban forests contribute to the global cycle. In addition, the number of urban forests in the eastern and southeastern Anatolia region is quite low. Establishing urban forests in these regions is important in terms of their contribution to the natural environment. Thank you.
Thank you very much.
Prof, are you here? I think your connection frozen. Yes, she's frozen right now. Okay, while we are waiting for her, I would like to add some comments about your work. I would like to congratulate you about your study, but I realized some key points that may be useful for your future studies. First of all, your data points are not homogeneous across the country. Therefore, using inverse distance weighting can be a bit problematic due to the fact that you don't have homogeneous intervals between those points. I recommend you to use some sort of regression algorithms in machine learning approach. And also IDV is a sort of old method. It has been widely used in the literature in order to have an original, in order to increase the originality of your methodology. I recommend you to use other algorithms which are not statistical based. They should be a bit machine learning, artificial intelligence based in order to improve the originality. And on the other hand, the last map, combining all the layers in one single map is an original idea. And I have also bumped into this map in your previous work about dentistry.
Yes, yes.
I remember the map, but it seems a bit complicated in terms of semantics and, let's say, aesthetic ways. You can improve the semantics of this map in order to have a better illustration, I think. So this is these are my concerns, but I would like to congratulate you again.
Thank you.
By the time we are waiting for Prof. Demirel, I think we don't have any other questions from the audience. So let me check whether the prof is here. No, I think she's locked off. So thank you.
Thank you.
For your participation and give our regards to those colleagues working there in Izmir. So since Professor Demirel lost the connection with us, I have to close the session for the Cartography and Geographic Information Systems second. Thank you for your participation. We have two extra presentations now. Just I need 1 minute and we will start again. Thank you. So we have an extra session. Two presenters will present this. From Abtakakka will present first. So please share your screen with us. Miss, you can start now.
Okay.
Thank you.
Okay. Okay. Good afternoon. Good afternoon. My name is Atakaka. I'm here to present the topic titled Digital Terrain and Detail Mapping of Parts of ABU Phase 2, Kaduna State, Nigeria. And my co-authors are Abdulmajid Buhari and Lukman Giro. Now, Ahmadu Bello University is one of the largest universities in the South Sahara Limpopo Desert, and over time, the population of the students have increased, and the land mass is over 50,000 hectares. So there is need to reconstruct more classrooms and more offices for staffs and students in order to expand the university so that you can be able to accommodate more people from the university. Now they can have the spatial location of where A and where what is. Now with the use of the differential GPS, the detailed structures were actually carried out in this study. Now the method that was employed was control extension to the project site, then the data acquisition process, that's from taking the whole perimeter survey, that's working from whole to parts, then the details in the whole study area, then the downloading and processing of the imagery, the mapping process, which include the production of the perimeter plan and the detail map, then the data interpretation and results. Now, on this table here, you can see the controls which were gotten from the Department of Geomatics, Ahmadu Bello University. Here is a Recce diagram of the study area, which was drawn not to scale. Then this is the perimeter survey map of the study area in question. And here is the arc view map of the study area of the classrooms. This is glass technology, geomatics department, and the rest. So here is the final produced map, the glass technology, the MOX, the building department, URP department, geomatics department, and the lecturer, then with the trees around it. Now, in about 1.0168 hectares was measured from the perimeter survey as the total area of the study area, and both natural and artificial features within the study area were actually identified. The 4 departments, which include the glass technology, glass and silicate technology, the geomatics department, urban and regional planning, and building department, were also located. Features like manhole, vegetation, roads, security lights, high tensions, and the rest were also identified. Then the final detail map of the study areas were produced in accordance with the survey rules and regulations. Now, in conclusion, the project's work was actually carried out in accordance with the survey rules and regulations. Then the authors would like to acknowledge the Ahmadu Bello University Diplomacy Department for the controls gotten for them for the essence of this work. Thank you.
Thank you so much for your contribution. I'm waiting for the answer, the questions from the audience, but so far there has been none. Would you like to add additional comments, Hande Demirel, if you listen to the presentation? Because
yes, unfortunately, I lost the Zoom connection. I missed quite a bit of Ms. Akaka's presentation. But I have to say, I'm very happy to be here today with all the presenters and the audience, because it's a very young and enthusiastic session, I think. And I am very happy to see that the geomatics engineering and the geomatics science is getting somehow becoming more popular and distributed towards everywhere.
Thank you, Professor, for your contributions, and we are looking forward to having you as a chair again for the following events. Thank you so much.
Yes, of course, I will be very pleased. I will be very happy, and I'm eagering for the presentations that we are physically together, and then we will also have some social networking and know each other better.
Exactly. So have a nice day, and give our regards to the colleagues at Istanbul Technical University. Thank you.
Okay, sure. Thank you very much, and thank you very much for all contributions.
Thank you. We have a question from Adamu Bala to Ms. Attakaka. What is the order of the survey?
Actually, the order of the survey is actually a second order control extension. We actually carried the second order control extension to the project site to establish the boundaries, and which we actually maintain that order for the picking of the details.
Okay, thank you so much. We can proceed to the following presentation that normally scheduled yesterday. We had a microphone problem. Ahlem Nezrek from Spain. She can start her presentation now. Let's check the microphone now.
Yes. Do you hear me?
We can hear you perfectly. Yes.
Okay. Okay, thank you.
Ms. Kaka, can you unshare? Okay. Go on, please. You can press the green button underneath the screen in order to share your screen.
Yeah. Okay. Good morning. I'm Ahlem Nezrek. I'm a PhD student of the University of Almeria, and we're going to start. The theme of the study is use of photogrammetric technique for virtual modeling of historical heritage, and the application is about Santa Barbara Bridge in Almeria in Spain. The aim of the study is the virtual reconstruction of the Santa Barbara Bridge in Huercal Ovela in Almeria. For this purpose, two techniques was combined. On the one hand, we have photogrammetric technique to carry out a survey of the current state, and the other hand, architectural modeling software to reproduce the original state of the bridge. Complementarily, it has been essential to collect historical information that allows us to adjust it to the reality built in its day. For our study, we're interested in the bridge of Santa Barbara, which was built after the General Road Plan of 1864. The iron bridge of Santa Barbara was destroyed around October 1973 by a huge flood that Almeria suffered from it. As we said before, the main objective of the study is the virtual reconstruction of the Santa Barbara Bridge, combining two techniques. The first one is the 3D modeling of the current state through UAV photogrammetry. For the photogrammetric survey, we use a DG Phantom 3 professional drone with a camera model FC300 with a resolution of 4,000 per 3,000. The flight was carried out at a height of 33.1 meter above ground level and taking a total of 841 photographs, used zenithal of the hull and oblique photographs of detail in the area of the abutment. To obtain the support point for the photographic survey, we use a Trimble GPS with R6 received with the base located in the European Terrestrial Reference System. And a total of 25 points were measured. However, only 15 points were used to adjust the photogrammetric project. The photogrammetric process was carried out using Agisoft Metashape software, formerly called Agisoft Photoscan. In the process of aligning images, the software is able to calibrate the camera, and this process allows to detect the points and obtain the orientation and position of the camera. Thus, a dense point cloud is obtained, a model, a mesh, and is generated, and then texture is applied. At the end of the process, an orthophoto is generated when we can see the ground control point we have worked with. This orthophoto serves as a basis for measurements. The second step of the virtual reconstruction of the bridge is the 3D modeling of the original state. First, we use the software AutoCAD to extract the 2D geometry of the bridge from the 3D point cloud model data. The passage from Agisoft Photoscan, Agisoft Metashape software to AutoCAD requires exporting the photogrammetric model in RCS using the Recap software. We use upper section plane at different level to know the width and length of the bridge supports, as well as the span of the arc. We can see it in the figure. The front section plane allows the height of the architectural elements to be obtained. The extract 2D drawing will be exported in DWG format to the SketchUp software. It has been necessary to pre-dimension the arc due to lack of information. According to the work of Rebellion, the height of the arc is 10.62 meter. The arc width is 0.2012 meter, and the arc thickness is 1.062 meter. The 3D model was georeferenced and placed on the digital map imported from Google Earth in SketchUp once the model was finished. In the absence of the original plan, photographs and the geometry imported from AutoCAD have been the main source for an objective modeling of the bridge. The bridge, a bowstring type, it has a deck distributed in 13 equal spans. Each span has a main support that has the same interior width as the arc, with 2 suspenders and a gasket connection point. The next phase was managed in the Lumion environment to build a 3D environment and add texture and materials. We will see it in the results after. Both software, SketchUp and Lumion are compatible. Therefore, the 3D model can be opened in Lumion in SKP format. Let's discuss the results. The model obtained from Agisoft Metashape, both in mesh level and texture, had the level of accuracy sought, having a multitude of photographs in the most hidden area, and the ability to move the UAV tool through the environment of the bridge. The position of control points influences the accuracy of the model, so it is important to distribute the points through the study area. The dense point cloud obtained by UAV photography using Agisoft Metashape had a total of 44,966,257 points. The mesh obtained had a total of 5,165,470 faces and 2,589,219 vertices. The final model is referenced according to the real coordinates in SketchUp. The tree model and the section obtained can be considered as a basis for further detailing the projects, because in the end, the most important thing is to have detailed technical information in order to achieve information. In the figure, we can see different elements of the bridge. It has an arc span of about 53.10 meter and a height of 10.62 meter from the bottom of the arc to the deck. Both arcs are braced together by 6 steel beams with an external section similar to the section of the arc in the last two, and increasing the section. In the center of the bridge, the deck has a width of 9.75 meter. It's composed of 6 longitudinal beams and 12 transverse beams of HEB type, 800 per 300. The transverse beams are distributed at 4.085 meter each one, where are also located the pendant vertical suspender, 24 in total, also carrying diagonal bracing. From this main support, the diagonal suspender, 2 for each one, 44 in total with St. Andrews cross bracing. We can see in the figure the final model of Santa Barbara Bridge with Lumion, with the objective of achieving a photorealistic finish which allows the construction of an information system of the engineering work to which all documentation and georeference and elaboration are incorporated. To conclude, the finding of the study shows that UAV-assisted photogrammetric technique can be a complementary method to achieve a 3D model. The most important advantages of UAV-based photogrammetry are cost effectiveness and flexibility, which allows obtaining 3D models with photorealistic texture with metric topographic texture materials properties. In this study, several fields have been exploited in order to model the Santa Barbara Bridge in its original state. For the purpose, photogrammetric data from photogrammetric survey, topographic data from Google Earth, architectural data from the combination of the section in AutoCAD and technical documentation, projectors in SketchUp, and the photographic data that has been the only source for the production of the bridge. All this to obtain a 3D dimensional reconstruction in order to obtain a model with optimal visualization quality.
Are we finished?
Yes.
Because you didn't say thank you, I'll complete.
Yeah, thank you.
And also some construction began.
Yes, I'm at work.
Actually, I would like to say that our department at Mass University is very interested in photogrammetry projects like we do. So if you want to cooperate with our team, please write down an email to our chair because we also do, our department also does similar projects in this area in order to cooperate with you and with your supervisor. Can be a better choice. And also for the publications, we have English language publications specific for cultural heritage and laser scanners and photogrammetric products. That's all I have to say. Thank you.
Can you repeat?
Our head, Murat Yakar, Professor Murat Yakar, is very interested in so in order to have some kind of cooperation, you can write down an email to him. And we have some journals. And if you do some similar projects, you can submit your manuscripts directly to our journals. I invite you for this kind of things.
Oh, yes, for next project.
Do we have a concluding remarks?
Yes, thank you very much. I would also like to mention that from the old images that were not taken photogrammetrically, but they are taken with an amateur camera, you can reconstruct a three-dimensional object with using different methods and techniques. So, I mean, you could, as Professor Iban said, there are many cultural heritage documentation ongoing, projects ongoing in Turkey. So I would suggest to make a cooperation in that sense. Also, you can also do a cooperation with us from Istanbul Technical University. But I think from old images, from old pictures, photographs, you can reconstruct a three-dimensional object if it's possible. And also, it will be nice to have a laser terrestrial scanner to scan the available monuments that's already there to have a cross-sectional complementary information.
Yes. Yes. Okay.
Okay, so I think it was very fruitful. I would like to thank Professor Yakar and Professor Ivan for invitation, and I will leave the floor to John then.
Yeah, you're always invited. Thank you. And we have a lunch break till 1:45. Thank you for the participation. I will assign the next panelist in 20, 25 minutes later. Thank you. Have a nice lunchtime.
Thank you. Okay.
Good afternoon, everyone. I think we are ready for the next session entitled as Geographic Information Systems and Cartography 3, which will be chaired by Associate Professor Dr. Halil Valizadeh Kamran from Iran. There will be 7 presentations registered in this session. The session is yours, Prof. Thank you.
Thank you very much, John. Hello, everyone. My name is Khalil Valizadeh Kamran from University of Tabriz, Iran, Department of Remote Sensing and GIS. Today, I have the honor to organize this session as a chair, and I hope that this online event would be very useful and informative for all participations. Our session name is Geographical Information System and Cartography. For this session, we have 7 speakers from different departments and interesting topics. We are going to present it. The first speaker will be Mr. or Mrs. Sokohan Chinahat, Neng Cheng Chen, and Harun Zheng. And his topics is development of urban growing space classification using landscape pattern analysis on GIS and remote sensing in Pattaya, Thailand. We kindly ask Mr. or Mrs. To have his or her time, especially in specific time. And if other participants have a question, they can also text me here. Mr. Sofowan Jirahat, please start.
Okay. Good afternoon, everyone. I will share my screen.
Okay.
Can you see my screen?
Okay, please press it. Okay.
Okay, good afternoon, everyone.
Please proceed. Okay.
I'm very pleased to be here. I am Sopapan Chinabut, student of SCGI Master Program from Burapha University and Wuhan University. Today, I would like to present my research about analysis, urban green space classification using landscape pattern analysis based on GIS and remote sensing in Pattaya, Thailand. This is my overview of content that I will talk: introduction, study area methodology, result, discussion, and conclusion. Let's start with introduction. Urban green space is one of the important elements in city for environmental conservation. It has a good impact on the environment, and its accurate estimation is of significance to guide the future urban planning management and environmental protection. The Thai government established a mega project called the Eastern Economic Corridor or EEC, and Pattaya is a part of EEC for the economic development. During the process of urbanization substitute natural areas, the population of urban green space didn't keep up with the speed of urban growth. And many research on green space landscape pattern in megapolis and provincial capital, but in the explosion in small area and medium area city is still rare. Objectives are explore the urban green space classification that represent the structure and function, and analyze the quantity and distribution of urban green space using landscape pattern analysis. Study area in this research is Pattaya. Pattaya is a city in Thailand, a self-governing municipal area located on the east coast of the Gulf of Thailand in Banglamung district, Chonburi province. It is approximately 150 kilometers from Bangkok, a total area of 50.19 square kilometers. In 2019, it had a population of 119,532. Therefore, the population density is around 2,000.
Miss Chinabut, sorry for interruption.
382 per square kilometer.
Miss Chinabut, sorry for interruption. Could you increase the volume of your microphone, please? Because you're hardly heard.
Pardon?
Could you increase the level of your microphone, please? Because you're hardly heard.
Oh, okay, teacher. Let's move on to methodology. This sound is okay or not?
It is better.
Okay.
Please proceed.
Let's move to the methodology. This is methodological framework and data acquisition. Kaya satellite is high-resolution Earth observation. Covering the study area was due to develop against space classification record on December 15, 2019, and land use data in the right side. This study was collect land use data on shapefile on 2010, 2016, and 2020. The source from Land Development Department. Data pre-processing. Digitization can visual interpretation on the color difference, roundness of texture, size, shape, pattern, and make a database in a geographic information system. Manual digitizing is still a useful technique because of its ability to accurately copy map in poor conditions. Because of high-resolution satellite imagery making us realize that this object is and more accurate than computer. Classification of urban green space including six types: natural green space, amenity green space, functional green space, linear green space, economy green space, and abandoned green space. This is an example of classification. Next to data analysis, landscape pattern analysis was conducted to quantify of each criteria of urban green space. Six landscape metrics include total cast area, mean patch area, number of patch density, channel diversity index, and channel evenness index. All landscape metrics were calculated using FastStat program. The first, result of the spatial temporal change of land use during 2010, 2016, and 2020. Urban and building up show a sharp increase in 4.98 square kilometers from 2010 to 2015 and 1.42 square kilometers from 2016 to 2020. Miscellaneous land show a sharp decrease since 5 square kilometers was lost from 2010 to 2016 and 0.93 square kilometers from 2016 to 2020. Second, result of the population of each category show type of abandoned green space has highest area, followed by functional green space. Third, result of the composition of patch and patch type level of urban green space landscape show abandoned green space has the highest number of patch and patch density, followed by functional green space, natural green space, linear green space, and amenity green space, while economic green space is the lowest. Also, abandoned green space has the highest mean patch area, followed by natural green space, economic green space, functional green space, and amenity green space, while the lowest is linear green space. Move to Discussion and conclusion. The study area in Pattaya has total area of 50.19 square kilometers, and the total area covered by urban green space is around 8.3 square kilometers, or 15.57% of the total area in Pattaya. The proportion of abandoned green space is the highest, and economic green space is lowest. If not counting the abandoned green space because this is an area that cannot be accessible and useless, there will be only 3 square kilometers of green space that people can use. World Health Organization says that one person needs 9 to 15 square kilometers from green space, but in Pattaya only have 5.81 square kilometers per person. It shows that Pattaya has much less green space than the standard. It is inadequate to meet the needs of people living in the area. The landscape pattern value it indicates that amenity green space and economic green space type is extremely scarce. It is important, therefore, to consider the provision of amenity green space in the context of urban planning and management in the future. Thank you for your attention.
Thank you very much, Mrs. Chinabut. Everyone have a question? Okay.
We haven't received any question from YouTube and Zoom, sir.
Okay. Mrs. Chinabut, I think the Pattaya area is a very touristic area in Thailand. Our relation between this tourism and the increasing of tourism and the city green space in this area?
Yes, Pattaya is an area of tourists. Many tourists in there, and in Thai government have a mega project for develop this area, and I think this space should be developed with economic space.
Mm-hmm. Thank you very much for the interesting topic. It was useful for all of us, and thank you for your presentation.
Thank you so much.
Thank you. Dr. John, the other presenter
is Mr. Cavit Berkay Yılmaz.
Okay. Okay.
Can you hear me?
Okay. Okay, Cavit. Please share your screen.
Can you confirm the screen is shared?
Okay.
It is better to have it full screen. Thank you.
Thank you.
Greetings from Turkey. I'm Cavit Berkay Yılmaz, doctorate student at KTO Karatay University in Konya. Our topic is trend analysis of temperature and precipitation data of 9 stations located in the Mediterranean region. Climate changes affect the entire ecosystem over time, causing the significant changes in hydrometeorological parameters. For this reason, performing analysis of these parameters is of vital importance in detecting extreme situations that may occur over time. Trend is defined as a statistically significant decrease or increase in the measured values of a parameter over time. Since hydrological sizes are of randomly changing character over time, spatial methods should be used to investigate the tendency to decrease or increase. In this study, linear trend and modified Mann-Kendall trend methods were examined using the annual average temperature data and the annual total precipitation data between the years 1960 and 2020 of 9 stations in the Mediterranean region. Study was performed in 95% confidence interval. If I'm going to talk about the study area, Mediterranean region covers the three major basins, namely the Eastern Mediterranean Basin, Antalya Basin, and the Western Mediterranean Basin. The region is of great importance in agriculture and tourism. The region, which has a Mediterranean climate, receives hot and dry summer and warm and abundant rainfall in winter seasons. When the table containing statistical information on temperature and precipitation data is examined, the temperature data mostly distributed symmetrically except for Antalya station, and all of the stations are found to be flatter than the normal distribution curve. When the same examination applied to the precipitation data, 6 of the 9 stations found to be symmetrically distributed. All of the stations found to be flatter than the normal distribution curve. Linear trend test is a parametric test that assumes the data is normally distributed and used to determine the presence of or absence of the trend in time series. This method's application is mainly based on graph and a line fitted to this graph, and the t-test to determine the trend curve. Modified Mann-Kendall test. In the original Mann-Kendall test, although the procedure is assumed to be independent, a correlation is observed in most of the hydrological events, and the presence of positive autocorrelation increases the possibility of detecting a significant trend. In order to eliminate this situation, variance values calculated with the help of the equations shown below, and the rest of the test is carried out similarly to original Mann-Kendall test. After the application, calculated z-value compared with the z-critical value to check statistically significant trend presence. Results in the study, linear trend and modified Mann-Kendall trend analysis were examined using the annual average temperature data and the annual total precipitation data between the years 1960-2020 of 9 stations in the Mediterranean region. The obtained results were mapped with ArcGIS software and visualized. The main purpose of this application is to concretize the trend results obtained and to determine their distribution over the region. If we examine the test results for the temperature data, it is seen that both of the trend tests shows an increasing trends. Antalya region is an exception in this table because of the sample size is less than 30. You can see the maps below. Left side is linear trend test results. Right side is the modified Mann-Kendall test results. It is seen that both of the tests shows an extreme case of increasing trends in 2 stations, namely Kahramanmaraş and Mersin stations. If we apply the same examination to the precipitation data, it is seen that no trend has been detected in the stations. So there's no map created for these data. As the test results for individual stations, only Mersin station will be examined as an example. As it's shown in the figure, when the annual average temperature graph is examined, a clear increase in temperature data over the years and statistically significant trend case of increasing trend is observed for both tests. And increasing trend can be observed for precipitation data, but this observation is not statistically significant for both tests. While temperature data generally gives high R-squared results, the R-squared values obtained from precipitation data is much more lower. Mainly, this means the linear projection of the linear trend test does not fit well to the high fluctuations of precipitation data. But trend results obtained from tests are quite compatible for both tests. Increasing trends in temperature data expected to increase more in the near future. These increasing trends in the temperature data indicates an increase of demand in the limited water resources, and the relationship between temperature and humidity might affect the number of storms that will occur in the near future. For temperature data, stations that shows trend presence are in accordance with other studies. When the results from both tests examined for temperature data, both tests show an increasing trend in 8 stations, and 2 of these stations has an extreme case of increasing trends. When the same examination was applied to the precipitation data, the results show no significant trend, and this situation is acceptable for both tests. Thank you for your interest in the subject. If you have any questions.
Thank you very much, Cavit Berkay Yılmaz.
It was my pleasure.
If anyone have a question? No. Mr. Cavit, you mentioned that increased temperature from 17 to 21 in your study area. It's okay?
Yes.
It is a great increasing in temperature. Do you have an idea about this great increasing in this area?
This mainly comes in some of the studies shows an increasing, how do I say it, activities in the industrial regions shows a main application.
Okay.
And there's an increase in the seasonal trends. Mainly summer season shows a bigger touristic influence, and mainly most of the hotels and touristic areas are open in this season. Thus it shows an increase in the summer season.
Okay, thank you very much. I'm going to share with you some of the comments that maybe improve your study in future. It is a very good idea to find the relation between the land change, land cover change, and the increasing in the temperature in your study area. Thank you very much, Cavit.
It was my pleasure. Thank you.
Thank you. And the other topics is creating and evaluating pollution distribution map in Asian region by using Geographical Information System GIS and air quality data. Ömer Bilgener, Elif Akhil, Güzide Miray Perihanoğlu ve Sena Tekavcı.
Thank you, Professor.
Okay.
Can I start?
Okay, please proceed.
Thank you. Hello there, participants. I'm Ömer Bilgener from İzmir Kağıt Çelebi University. In this session, I will talk about creating and evaluating pollution distribution map in Asian region by using GIS and air quality data. As you know, global warming is the biggest threat to the world. Global warming is the increase in the temperature of the Earth's surface and atmosphere as a result of the increase in amount of greenhouse gas like carbon dioxide, methane, ozone, etc. released into the atmosphere. So, in this day, air pollution seriously threatens future generation. So what is the air pollution? Air pollution is environmental problem that occurs as a result of the increase of foreign substance such as dust and gas, etc. in the atmosphere to more than normal amounts and negatively affects the health of living things. The first date that case from air pollution was recorded in London in 1873, and it was stated that these deaths increase every year. The air pollution increased dramatically and day by day in our country as well. The cause can be shown as unplanned and rapid urbanization, incorrect choice of location in an industrial zone, and pollutants coming out of chimneys. We can divide air pollution into 2 groups as natural and artificial cause. Natural causes have a local impact on air pollution. Artificial causes affect the world on a global scale. That's why artificial clouds are the most important factor in air pollution. Air pollutants are shown as carbon monoxide, sulfur dioxide, hydrocarbons, nitrogen oxides, and particulate matter. I will talk about sulfur dioxide and particulate matter. Sulfur dioxide has a property of being a poisonous gas for all living things. This gas occurs as a result of the use of coal for heating purposes. And where urbanization occurs, sulfur dioxide is known to have higher value. Particulate matter is divided into aerodynamic diameters in terms of mass and composition. Particulate matter 10 notation is used to describe particles that are 10 micrometers or smaller, which have been selected for this study. In this study, we examine the data from January, February, and March in 2018 and 2019 from the air monitoring station in the Asian region in GIS, and it has been determined whether it has a decreasing trend. Study area. The Asian region is the second largest industrial region in Turkey after Marmara region. It is seen that the automotive, oil, and mining sectors have a significant share in air pollutant due to the intensification of these industries in the Asian region. Material methods. First of all, material is the data to be used in the study were obtained from observation stats in province in the Asian region. The data were downloaded from the databases of National Air Quality Monitoring website. In this study, spatial analysis of air pollutants, sulfur dioxide, and particulate matter 10 were mapped using inverse distance weighting interpolation method in ArcGIS program. So what is the inverse distance weighting interpolation method? The value of the points that need to be estimated with inverse distance weighting are calculated by averaging the values of the sample points around each point. The effects of the points to be predicted is greater and more distant points have less effect. Results, when we look to figure 2 and 3 are examined, it is seen that amount of particulate matter 10 increases in Kütahya and decreases in Afyon and Uşak. The most important reason for the high air pollution in Kütahya is the coal-fired thermal power plants in the city. Air pollution limit value of particulate matter 10 is 40 microgram per cubic meter in our country. When figure 2 and 3 are examined, it's seen that the particulate matter 10 limit amount has been exceeded in the Asian region. The second figure is figure 4 and 5 are examined. It's seen that the data distribution of sulfur dioxide in the provinces in the Asian region has decreased 2019 compared to the previous year. The air pollution limit value of sulfur dioxide is 20 microgram per cubic meter in our country. It's seen that many provinces in Asian region exceed this limit value. Considering to these years, Izmir is the cleanest province in the region in terms of sulfur dioxide amount. Conclusion, today, air pollution is a global threat that affects future generations. In order to improve air quality, especially the increase of natural gas should be encouraged. If natural gas cannot be made widespread, the use of high-caloric coal for heating should be encouraged and attention should be paid to the thermal insulation in buildings. Industrial facilities should be located outside of the settlements and the prevailing wind direction should be taken into consideration. This is my references. Thank you for your attention, Professor.
Thank you very much, Ömer Bilgener.
Thank you.
Your topic is very great. Everyone have a question?
I have a comment, sir.
Okay.
As I stated also to Elif, I recommend to apply also other interpolation and regression tools for your data, because IDV methods sometimes do not work well with the very heterogeneous data sets. So in order to have more comprehensive and more realistic predictions, I recommend you to use machine learning prediction methods for this kind of purposes. Thank you so much.
Okay, thank you.
Thank you very much, Can. Ömer, why you select IDW method for your interpolation?
We choose this one because of the previous study choose this method. We tried this Asian region. That's why we choose this method.
Thank you. IDW is a very good method for spatial distribution. Thank you, Ömer. And our fourth present is under topic determination of effective predisposing factors using random forest-based Gini index in landslide susceptibility mapping. Alihan Teke and Tashkan Kavazoğlu.
Yes, sir. I'm here.
Okay.
I will share. Just a moment.
Okay, share your screen.
Is it okay now?
Okay.
May I start?
Okay, please proceed.
Good afternoon, everyone. I hope all of you are doing well. Before starting the presentation, I'd like to thank the organizers for providing an opportunity for presenting our paper at this online conference. And first, I'd like to start with introducing myself. I am Alihan Teke and currently working as the research assistant in the Department of Geomatics Engineering at the Gebze Technical University. And this presentation today concerns primarily on the determination of the most effective landslide predisposing factor using the Gini index feature selection algorithm, which is based on the random forest classifier. And here is the general concept of the presentation. I have divided the presentation into 6 main sections that I need to highlight. Outlines of the presentation will be introduction, methodology, study area, application, and finally results and conclusions. As you know, globally, landslides have been considered as the major geological disaster that caused to property damages, economic devastation, casualties, and injuries. Therefore, correct identification of potentially vulnerable zones towards the landslides is of utmost importance. And thus, we can take the preventive measures to avoid the serious consequences of the landslide activity. And here's my methodology. One of the main challenges actually in the generation of landslide susceptibility map is the determination of the correct features that reflects to main characteristics of the study area. However, in the current literature, there is no universal guideline or framework about selection of these factors. There exist actually several reasons underlying this issue, but the most leading one is that each study area has its own specific characteristics. Actually, more specifically, I mean a factor, a landslide predisposing factor positively affects the model performances in a given study area, but the same factor may have no or even negative effects on another study area. Therefore, we suggested an approach in this study, and in this slide, I will explain the main steps of this approach. Firstly, based on the in-depth literature surveys and the properties of the study area, we defined the 16 main landslide contributing factors. Secondly, the importance scores of these factors were calculated using the Gini index-based feature selection algorithm. Later, considering these scores, which is obtained by the Gini index, 3 data sets with variable numbers factors were created. I will mention details of the dataset in the following slides. And finally, the random forest algorithm was employed to determine landslide susceptible areas. And also, it should be noted that grid search-based hyperparameter optimization was employed to determine the best values of hyperparameters, and which is applied in the Python programming language. And here is the study area. The Araklı district of Trabzon province, situated in the northeast part of Turkey. It is selected as the region of interest, and it covers an area of about square kilometer of 479. And the large part of the study area is mountainous, with elevations varying 0 to 2,876 meters, and slopes up to 70 degrees. And also, heavy rainfall and anthropogenic factors make a substantial contribution to the occurrence of mass movements. And here is the landslide predisposing factors that considered in this study. In the process of reliable generation of landslide susceptibility maps, another important step is the preparation of predisposing factors. Some of them reflect the morphological, topographical conditions of the study area. On the other hand, some of them shows the environmental, hydrological, or anthropological properties. As you can see, which are the of landslide predisposing factors, which are distance to roads, slope, stream power index, topographic position index, elevation, NDVI, distance to rivers, road density, and also lithology, valley depth, curvature derivatives, and etc. As I said earlier, in this study, random forest classifier was utilized. Actually, it is a solid ensemble learning approach whose working principle is essentially based on the combining many decision tree. And to assess the predictive performances of the model, about 2/3 of the instances, or also called as simply in-back instances, are employed for the model training phase. While remaining, or also called as the out-of-back instances, are employed for the internal cross-validation procedure. Also, several metrics, which are relatively cost-effective, have been proposed to calculate factor importance score using random forest. Among them, the Gini index, or also called as mean decrease impurity, is widely preferred by the researchers to measure the importance of features. And Gini index is essentially a splitting function utilized by the random forest algorithm to specify which feature to split on through the learning stage. And here is the first step of the application. As you can see in the figure 3, the importance score of each factor was calculated through the Gini index algorithm. And also it should be mentioned that the higher score of Gini index indicates the higher importance. And to put it briefly, the figure 3, slope with 0.358 is the most effective landslide predisposing factor, while plane curvature with 0.009 is the least effective one. And also, considering these values, 3 data sets created as seen in the table. The main purpose of the process identified the effects of the number of the factors on the model performances. And the first data set, RF1, consists of the whole data set. The second one, RF2, consists of the 12 factors, and it means 75% of the entire data set. And the last one, RF3, contains 8 factors, and also it means the half of all the data set. And after creating the 3 data set, these were separately trained using a random forest classifier. And also it should be noted that overall accuracy and area under the curve value were considered to compare the results. And also to make a sound comparison, statistical significance test, which is McNamara test, was also utilized. Here are the results, as you can see. When we check the results, the RF2 model had the greatest overall accuracy with 93.28%, and followed by the RF3 and RF1 models. And Similarly, when it comes to the AUC value, the RF2 model had the highest AUC value, 96.70%, followed by again RF3 and RF1 models. And also, apart from these accuracy assessment measures, as I said, the statistical significance of the difference between the performances of the models was also analyzed using McNemar's test. And in this test, if the estimated statistical value is higher than the chi-square table value, which is 3.84 at 95% confidence interval, it can be then said that the difference between the results of two independent models is statistically significant. And simply, in other words, the model outperforms the other model. And according to estimated statistical value test results, it was observed that three models yielded statistically different results. And also, to sum up all of this, several conclusions can be drawn based on the results of the present work. Firstly, it was observed that the RF2 model consisting of 12 landslide causative factors was found to be more efficient than other models. And also, 25% of the whole data set was curtailed, which also elevated the training time and the model complexity. When utilized the RF3 model containing of 50% of the whole data set, significant decrease in the model performances by about 10% was observed. The RF2 model, which is determined as the optimal model, was employed in the production of the landslide susceptibility map of the study area. And the last but not least, it can be observed that the RF algorithm, random forest algorithm actually, employed with the correct features, correct attributes, were yielded highly accurate results. And I would like to end my presentation with an expression that states, float or unnecessary data produces nonsense output or garbage, and that a very central place in many domains, especially in our domains, geography information science, is that garbage in, garbage out. Thank you for your attention and listening.
Thank you very much, Alihan. Everyone have a question?
I have a question, if you mind.
Okay.
Actually, I liked it very much. Congratulations about your work. Pure machine learning. That's very impressive. Fruitful presentation, by the way. But I would like to ask you about your importance score. Could you return back to the slide again? The importance score slide. Did you do any cross correlation matrix like a heat map in order to understand the relationship between these parameters?
Yeah, I didn't do that.
Actually, I recommend it because in order to understand the weighting factors, because you do not assign any weighting factors since you obtain it from the random forest approach, it is better to use such a correlation analysis because if there are a lot of uncorrelated materials, factors in your research, maybe the accuracy can be biased. In order to test it, I recommend it. It's a basic heat map that you can straightforwardly obtain from scikit-learn or any other machine learning library in Python. In order to understand the relationship between these parameters, it's a very crucial and very important step in the very beginning of your analysis. I recommend it. Thank you so much.
Thank you so much.
Thank you, Alihan. Please stay in this slide. Alihan?
Yes, sir.
Okay. Alihan, as you mentioned in that table, the slope was your effective factor for landslide, okay?
Yes, sir.
Okay. You think that the increasing in a slope take place landslide better?
Yeah, actually in the literature, slope is the leading landslide predisposing factors. And also some researchers have considered these factors to create the non-landslide samples. For that reasons, it's really important.
Normally in a low and high slope, Ali, Alihan, normally in the high and the low slopes, landslide don't take place. In the suitable decrease of a slope, the landslide take place, and you can consider this factor in your future study. Thank you very much, Alihan.
Thank you for your constructive comments.
Thank you. Okay, and our other topic is a trend analysis of precipitation data using Mankendel and sense slope tests. From Osman Enes Güneş, Aslan Cihat Basara, Yasemin Shishban. Are you here?
Yes.
Oh.
Can you see?
Okay, it's excellent. Please proceed.
Hi everyone, I'm Osman Enes. I'm a graduate and a student at 19 Mayıs University. I will make a presentation titled Trend Analysis of Precipitation Data Using Mankendel and Sense Slope Tests. Change in meteorological data is a complex natural hazard that causes the draw and affects ecosystem and society in many ways. Draw risks should be assessed in order to minimize the effect of draw, which is a result of change of meteorological data. Meteorological events on Earth have unfixed feature. Therefore, the size and consequences of meteorological change cannot be easily predicted. Changes in precipitation in a residential area can lead to important problems affecting human life. Change has significant effects on clean water resource and agricultural activities. For efficient use and control of water, meteorological data should be analyzed and evaluated. Thus, the meteorological data should be examined on the presence of any trend. While the continuous decrease in precipitation values, disasters can be observed such as drought and desertification. The continuous increased precipitation values, disasters such as landslides and floods. Therefore, trend analysis and disaster risk map in rainfall data have great importance. Tokat Erbaa Plain, which has an agriculture importance, was chosen as the study area. Material and method. In the study, precipitation data of Erbaa Plain of Tokat province were used. Precipitation data are taken from the NASA Langley Research Center power project. Monthly rainfall data for a 40-year period was obtained from the website of the project. Standard normal homogeneity test, standard precipitation index, Mankendel trend test, sense slope test were used as methods in the study. Standard normal homogeneity test. The data used in climate research should be sufficiently long and homogeneous. Data should only be affected by climatic reasons and not by artificial causes. The suitability of the data for analysis was investigated with the standard normal homogeneity test. Standard precipitation index. Standard precipitation index was proposed in 1993 and is used to identify and monitor drought in regions with varying climate. SPI values are classified according to the SPI classification table. Drought categories created with SPI values. The Mankendel method is a non-parametric method that is processed according to the presence or absence of change in parameters in a time series. It is determined whether there is a trend in the data using Mankendel test. In this method, the order of the data is compared. One of the advantages of the test is that the data does not need to any distribution. Sense slope test. The direction and size of the trend in the data are determined using the sense slope test. If there is linear trend in the time series, the actual slope can be determined using a non-parametric method. This method can be applied to acres that are not affected by data errors or extreme values and where there are missing values. Results. In the first stage of the study, the standard normal homogeneity test was applied to determine the suitability of the values in the dataset for analysis. Then SPI values were calculated for draw classification. The main candle test was applied to determine the direction of trends and statistical significance level in the data series. In the last stage, sense-slope test was applied to determine the trend directions. SNHD, homogeneity test result, there is no break on average. P-value is higher than the significance level. Data are homogeneous. SPI values have been calculated and classified. From the table, extremely and moderately humid in 1 year, lightly humid in 8 years, normal in 13 years, lightly dry in 4 years, moderate dry in 6 years. Very humid in 3 years, rainfall was observed. There was no rainfall in the extreme dry class. Sense slope result at 90% confidence interval. In this table, precipitation increase in January, March, May, June, and September. A decrease was observed in April, October, and November. No trend was observed in other months. SPI trend graphs. Monthly trends of SPI values. In this graph, we see the change of SPI values over time. While there is generally increasing precipitation in the Erba plain, draws have been observed in recent years. It has been observed that the decreasing trend was in the autumn months when the region receives the most precipitation. Also, an increasing trend was observed in the summer months when the lowest rainfall was observed throughout the year. The plans should be made in order to reduce the damage that may occur due to the negative effects of climate change. My presentation is over. Thanks for listening.
Okay. Thank you, Osman. Anyone have a question? Okay. Osman, your topic is very good, but where is the GIS rule in your paper?
My English is beginner. I don't understand.
Şunu demek isterim Osman.
Evet.
Şu makalede GPS konusu ilişkisi sizin makaleyle neymiş?
Bir ilişkisi yok. Sadece konumsal bazda Erbaa Ovası'na dair bir analiz yapmış olduk. Yağış verileri üzerinden. Trend analizi.
Yani şu bilirsiniz bu session yani GIS ve kartografi sessionu'ydu.
Evet.
Siz yaptığınız bu araştırma çok iyi bir araştırmaydı ama bunun yani ilişkisi GIS'ine ne olabilirdi? Onu bence yani daha önce de bir makale var idi. Onu interpolation sistemleriyle onu haritada göstermişti. Şöyle bir işler de yapabilirdiniz.
Evet, olabilirdi. İnşallah.
Tamam, teşekkür ederim.
Ben teşekkür ederim. İyi günler.
Teşekkürler. Okay. Thank you very much. Our other topic is investigation of the shadow effects of urbanization on green areas with shadow impact analysis from Halil Ibrahim Şenol.
Hello, everyone.
Hello.
My name is Halil Ibrahim Şenol. First, I want to introduce myself. I'm from Harran University's Geometrics and Engineering Department from Şanlıurfa, Turkey. I will tell you about my study that is investigation of the shadow effect of urbanization on green areas with shadow impact analysis. This is a new kind of analysis in GIS areas, especially near years 3D GIS is far more important in GIS. So the 3D analysis far more often in this area. First, I will start with introduction. Unplanned and rapid urbanization is one of the major problems in developed and developing countries. Unplanned urbanization resulting from migration causes difficulties in processing urban data and making plans. Therefore, the concept of smart city has been introduced to make future city plans smooth and effective and to make them sustainable. 3D GIS, 3D city models, which are generally used for visualization purposes, can also be used effectively for planning and development purposes. However, there are still problems in obtaining data suitable for 3D GIS because we still need the data from our local governments because they produce the data mostly, and there is still a lack of open data in our platforms. But I think in the future we will pass that. 3D GIS has been used for shadow and solar analysis for several years. Visualization is one of the main purposes of 3D GIS and 3D city models. 3D city models are also indispensable for many visibility analysis, such as determining the line of sight between the 2 points in urban area and predicting the volume of view. In this study, a park which is located in Diyarbakır, Turkey, and the construction around it has not been completed yet was selected. The reason that I choose the Diyarbakır region for the data is the OpenStreetMap data is available in Diyarbakır, mostly good data. So I use that as my data because I want to use an that's open data, free data for my study. Two scenarios are presented according to the existing structures around the park and the predicted structures expected to be built in the future. And the shadow effects of these scenarios on the park have been analyzed. Firstly, this is my study area. This is my study area. There is a park in there which is green. You can see on the map. It's near the airport and it's a developing part of Diyarbakır. So I choose there, and you can see the red shapes as the proposed buildings and blue shapes as the base buildings. The area of study was determined on OpenStreetMap, which provides open source GIS data, was examined to obtain the data of the determined study area. Building heights and sun angle are of great importance in the shadow effect analysis. For this reason, the study area was chosen as a park in east-west direction and with a small number of buildings around it. Firstly, I used the staging software to make the shapes in the 3D. I use just block shapes because I want to use them for their shadows. So I produce a 3D model in staging. The model produced are colored and divided as follows. As you can see, the green zone is the park area, blue structures are existing building area, and red structures are the proposed buildings area. For shadow impact analysis, I use ArcGIS Pro. ArcGIS Pro has a new tool methods called tasks, and development impact analysis. I use development impact analysis for that. In there is a shadow impact analysis. The shadow movements of the 3D models that were included in the shadow impact analysis were observed according to two separate situations. As you can see, there is a sunrise situations and sunset situation. I look at, you can see the shadow effect on the park area in the figures. To compare the shadow obtained in two different situations, first, the basic structures were analyzed and the shadow conditions were revealed. And then the effect of the proposed structures on the park was investigated if they were built in the area. As seen in figure, the effect of the proposed buildings on the park is serious. This can limit the possibility of providing sunlight to people, which is one of the biggest features of green space. In the analysis results, the sunshine duration was analyzed and the shadow boundaries formed on the park were revealed. As you can see the figures, in the left one, you can see the creating the shadows created by existing buildings. As you can see, there is a little shadow created in the existing building because yes, the existing building is cast the shadow too, but how many hours the shadow can be there? I looked at in the right figure. You can see the proposed buildings, the more sustained shadows created by the proposed buildings. You can see the figure that.
Okay.
The two shadow scenarios were compared with a separate analysis, and the amount of shading was revealed. As you can see, there is in the figure, the proposed building and base building, both the cast shadows, but the proposed building has more recast shadows, and you can see the difference in there. And the results and discussion when the shadowing times and amounts on the park are examined. Although it's seen that there is a serious accumulation of shadows, the amount of shading remained at a certain level since the building heights in the region have a certain limit. Shade areas are divided into areas that are mostly shaded, have equal shade and sun duration, and are not shaded. As you can see the figure, the equal shade areas, lower shade, and high shade. In conclusion, nowadays, the increasing amount of degradation in green areas and green area needs of people have led people to take various measures in the protection of these areas. Shade is an important factor in the benefit of green spaces and decreases the sunbathing effect. It is not correct to limit sunbathing periods due to construction, especially in this period during which many studies have been conducted on the beneficial use of solar energy. For this reason, the shading periods of places open to human use, such as parks, should also be taken into consideration while making city plans. Thank you for your attention.
Thank you very much, Halil Ibrahim Shenol. Anyone have a question?
We haven't any questions.
Okay.
Thank you.
Welcome. Halil,
yes.
Do you have a photo to show the effect of the shadow on the green space in this park?
Not now, because the proposed building has not built it in yet. So there is no shadow effect in that area too. For that, I suggest, mostly suggest the local governments to careful the construction around the park for the shadow effect.
Thank you very much, Khalil. It is very great.
Thank you.
Okay, and our last presentation is under title Spatial Flood Analysis to Determine Possible Economic Damage Case Study, the European side of Istanbul.
Yes, sir. Can I share my screen?
Okay, please. Thank you.
Good afternoon, everyone. I'm going to talk about our study that name is Spatial Flood Analysis to Determine Possible Economic Damage case study of European side of Istanbul. My name is Yusuf Göktuğ Bağcı, and you can see my team members on the screen. We are undergraduate students at Istanbul Technical University at Geometric Engineering. Also, thank you for the support, Professor Hande Demirel and American. When the flood disasters are investigated, climate change, increasing the concretion, unplanned urbanization, insufficient infrastructure, the flood productivity of topography, settlements in riverbands can be stated as the main causes. When we look at the problem, actually, the main reason why this impact of disaster could not be prevented is not a determination of possible flood zones or the failure to perform necessary analysis, but the fact that different sources of information are not presented and analyzed in a spatial environment. The proposed solution to prevent or manage the effects of possible flood events is to collect spatial and economic data from different sources in a single database and analyze and present this information to the decision makers in an understandable way by using the geographic information system. In this study, the flood analyses are performed in GIS environments, and the spatial risk assessment is made by using the economic input data for the areas determined as a result of the analysis. Study used data were completely obtained from open source database, for example, water bodies, buildings, roads, and point of interest obtained from OpenStreetMap, and then was chosen SRTM dam. It obtained from USGS Earth Explorer. For study area, when the past events of Istanbul examined, it was found that the flood causes more damage on the European side rather than Asia side. And for such studies, digital elevation model is the key input for determine the characteristic of topography and the floods effect. So we can say that one of the most important factors, the effect of the accuracy of flood analysis is the resolution of them. When the open source dams are examined, SRTM has the 30-meter spatial highest resolution. So we choose the SRTM dam. Unit prices is required for the damage assessments. Building unit price obtained from 2021 approximate unit cost of structure in Turkish Legal Gazette. Our methodology consists of two main headings. One of these determining the spatially inundated areas, and the second one calculating the economic damage of buildings and roads within these areas. We started the spatial analysis, flow direction and flow accumulation operations were performed using the dam of the European side of Istanbul, and then stream orders were determined using the flow accumulation results. The flood impact distance was determined to 500 meters within the help of the legal regulations. It means the stream order buffer zone has 500 meters wide. As a result of the analysis of floods in the past year in Istanbul, areas of below 25 meters have been identified as a risk areas. And finally, possible inundated areas were found as a result of the intersection, buffer zone, and risk areas. Second stage of our methodology is damage assessment. Determination of the inundated areas that occurred by floods and their economic damage is very important in terms of taking measures to minimize effect. While calculating the economic damage, the inundated road and building data were calculated separately by using their unit prices. You can see our study results. Many regions of Istanbul has possible inundated areas. Large-scale maps prepared for detail. You can see the right side of the screen. In order to increase the accuracy of economic damage analysis, the inundated buildings were examined under 4 main headings. Then the total damage was obtained by calculating the unit price on the basis of square meters for each building types, and total building damage was calculated $100 million. Within the same logic, the inundated roads were examined 3 main headings, and total road damage was calculated $420 million. You can see the distribution of total damage, and total damage was calculated $520 million. In the study, the areas that will be inundated in a possible flood in the European side of Istanbul are spatially determined, and the economic impact is calculated. The applied methodology can be implemented for all cities in the world where data is available, and its outputs can be shared with decision makers. Precautions should be taken via using such spatial decision-making system to reduce the destructiveness of floods that harm to people seriously. Thank you for your attention.
Thank you very much, Yusuf.
You're welcome.
Anyone have a question? Dr. Muzafferjan?
I was out of the office for a conversation. I'm sorry, I couldn't catch the half of the presentation, but I will check it in the YouTube records. I don't have any questions.
Yusuf, why you mentioned only economic issues, not human issues?
Actually, I mentioned how we determine the buildings, roads, the possible inundated areas. And after I start the economic analysis.
Understand. Okay. Thank you very much.
You're welcome, Sorte. Thank you.
Thank you. It was our last presentation. At the last, thank you very much for all presentations and participations. I really hope that this session was useful for all of you and could get some idea for your future research and collaboration. It was great pleasure for me, although as a chair, I indicated that I am from University of Tabriz, Iran, and from Department of Remote Sensing and GIS. Thank you. If you no question, close this session.
Thank you
Dr. Muzafferjan.
Thank you so much, Prof. We are so glad to have you as a guest and chair in this session, and we are looking forward to having you in these organizations following versions. Thank you so much for your nice contribution.
Teşekkür ederim.
I would like to also thank to all presenters in this fruitful session. So we can close this session, and the next section will start at 2:30, photogrammetry remote sensing 4. Till then, we have a break. Thank you so much.
Teşekkürler Muzaffercan. Görüşmek üzere.
Görüşmek üzere. Kendinize iyi bakın hocam.
Teşekkürler.
Hi.
Hello, Prof. Good afternoon to everyone. Now we're going to start the photogrammetry and remote sensing, the fourth session, which will be chaired by Assistant Professor Dr. Yo Kyung Han from Republic of Korea. There are 7 presentation. No, 1, 2, 3, 4, 6 presentation in this session. And we're gonna start in 2 minutes. We have only 1 author missing, and I have already assigned all the other presenters. So thank you, Prof, by the way, for joining us. And I think that it's kind of a bit late in the evening in South Korea. Am I right? I apologize for that.
No, it's okay. It's 8:30.
That's okay.
But it's still working time.
More late. I think we have 6 hours of difference between us, right? Yeah.
Yeah.
At least we are in the middle of the time zone, so luckily we can reach to most of the countries without reaching them in the sleeping time.
Yeah.
But we are so sorry about that. It's kind of late in the Far East right now. So the session is yours, Prof. Thank you so much for joining us. I will assign all the panelists when they enter into this chat room, and we collect the questions from both Zoom's chat section and YouTube live chat. In case of any question asked after the presentations, I will notify you. Thank you so much.
Okay, thank you.
Our first presenter is here, Professor Han.
Can I start? Hello.
Hi.
Can I start?
Oh, can you start now or we will?
Yes, it's 2:30. We can start now, Prof. You can start.
Okay. Hello, everyone. My name is Apakon Mongsit. I am a master student of Silinton Center of Geoinformatics program, Burapha University and Wuhan University. The topic for the presentation today is analysis and investigation on spatio-temporal dynamics pattern of drought in Thailand. Content of my presentation divided into 5 parts as follows: introduction, study area, methodology, results, and conclusion. Begin of introduction, statement and significance of the problem, the dynamic nature of drought cause differentiate in planning, monitoring, predicting, and providing assistance to drought-stricken area. Drought may affect people and agriculture at local scale or have impact on economic, society, and environment. Drought problem in Thailand is not a new issue, but is a representative problem, especially in Thailand. Drought is a natural disaster appear in many areas and is very damaging problem and difficult to national development. Cause of drought in Thailand, the most case is precipitation deficiency because of seasonal cycle variation of atmospheric pattern, namely in tropical region with wet and dry season emerging due to the movement of the intertropical convergence zone or monsoon trough. Remote sensing for drought condition is a method of observation and monitor the condition of large area with limited data and possible to create drought condition map of village area. Therefore, the main aim of this study to evaluate drought condition in Thailand from 2000 to 2020 for main indices which were widely used for drought. Representative of this study are meteorological index as SPI and vegetation indices as VCI. Indicator as SPI and VCI can generate the best correlation anticipation relationship for early sign of drought impact and drought monitor purpose. Study area cover Thailand. Thailand, located in the center of mainland Southeast Asia, have and compact diverse ecosystem. Thailand is composed of 77 provinces and has a land area about 500,000 square kilometers. This is a methodological diagram of framework in this study. Use typical drought indices produced from satellite data as VCI and precipitation from ground station derived data as SPI to describe the relationship between the drought indices and analyze the spatial temporal distribution of drought condition in the 21 years period in Thailand. Data used in this study are meteorological data is precipitation data from 95 land stations and vegetation data for what NDVI derived from MODIC to compute VCI. Data derived on a monthly period from 2000 to 2020. And compute SPI for monthly rainfall data to assess the wet and dry condition based on precipitation variable, and compute VCI from NDVI was derived from MODIC. VCI provide information on the currently status of vegetation. After that, evaluate for spatial temporal drought correlation of drought indices to investigate the relationship between SPI and VCI, and analyze for spatio-temporal drought based on indices to classify spatial drought level. For the result, meteorological, the average of 21 years annual precipitation is more than 1,600 millimeters per year. The highest monthly average rainfall between May to October. Drought indices analysis. In this study, historical drought in Thailand used drought observation with remote sensing data analysis of retrospective 21 years. Droughts found that SPI and VCI, the top average value was between October to December in 2004 and February 2005. SPI value was the lowest in December 2004 and highest SPI in June 2000. The highest VCI in 2010 and the lowest in 2001. For the correlation of drought indices, SPI and VCI that both indices have a low correlation due to VCI used as the indicator of the status of vegetation variation during that drought time that could show a slower drought than other indices. For spatial temporal of drought based on indices, occurrence of drought had based on indices. The drought indices analyzed were mainly depend on the precipitation. The difference in dry and wetness were observed area that occur in each time period. For determining the drought classification level for temporal and spatial drought analysis, the determine map identify area of drought and label them by intensity. There was 20 consecutive periods of intense drought, which were 2004 and 2016. severity and duration of doubt. The spatial extent or severity is classified with both doubt and no doubt. The temporal and spatial extent of doubt for every month from indices were analyzed, found that the number of years with VCI and SPI experience more than one time of doubt. Spatial temporal evolution, the spatial percentage of indices from doubt severity classification, the top doubt years by spatial extent or severity is classified as the most influential doubts occurring in December 2004 and April 2016 were the largest area of two indices. For the conclusion, the evolution of the doubt indices found the most doubt were the years 2004, 2012, 2016, and 2012. Usually start from the March to May and November to December. Evaluation of spatio-temporal dynamic of doubt in Thailand. The doubt was the worst in 2004 and the wetness in 2017. Almost all study area experienced more than one time the average number of doubt during the 20 years period within December 2004 and April 2016. The largest area of two indices. The result of the spatial and temporal analysis show that the mean of each index was consistent with the change in rainfall. Since Thailand is a dry season and there is a long period of rain, the SPI and VCI indexes are suitable for monitoring the accumulated doubt as well. Indices derived from satellites are an alternative method that can be integrated with meteorological data and evaluate and analyze the temporal and spatial doubt that in the analysis of the result and can be applied in time to the next situation. Thank you for your attention.
Okay, thank you for your interesting presentation. Is there any questions or comments from audience?
We haven't received any comments or questions on live sessions, Prof. But if you had any comments by yourself, you can.
Okay, I have just one small question. So you compare the SPI and VCI, but according to your result,
Yes.
There's no specific correlation between them.
SPI and VCI is some part of my work, and I add more the indices, some soil moisture and hydrological data, but for now, not finished to show that. And
Okay. Okay, thank you for your answer. Okay. Let's move to the next presentation. And next presenter is Ms. Lisha Ulutashi. Am I right? From Konya Technical University, Turkey. And the topic is using terrestrial LiDAR data in 3D CAD modeling applications. Please share your slides.
Okay, I'm sharing my screen. Can you see my presentation?
Yes.
Okay, good afternoon, everyone. My name is Nesliha Ulutaş. I am a master's student in Konya Technical University. As you can see on the screen, our topic today is using terrestrial LiDAR data in 3D CAD modeling applications. My presentation will consist of 4 titles. Firstly, our country has an extremely rich and important cultural potential that contains numerous historical and cultural artifacts. Although today's modern buildings are designed to withstand various events, historical structures have suffered many natural or human-induced damages until today. Architectural documentation studies for the transfer of these precious historical artifacts from the past to the present have proven to be an effective and useful method for the reconstruction and preservation of the building. Nowadays, different perspectives have been obtained in architectural documentation applications thanks to the increasing developments in measurement technologies and the integration of photogrammetry into architectural applications. Terrestrial laser scanning method has become a more effective and current method compared to traditional measurement methods for architectural documentation studies. Terrestrial laser scanning technique is basically evaluated within the LIDAR system. LIDAR technology is the name given to a remote sensing technology, commonly known as laser scanning technology, referred to as beam capture and distance determination. TLC is a method based on obtaining the XYZ coordinates of many points as a result of sending laser pulses to the target object and measuring the distance between the device and the target. A point cloud is represented as a function of the intensity of the reflected laser beam. Using 3D point cloud data obtained by laser scanning method, the following studies can be performed through CAD applications. For example, basic measurement data, orthophoto image extraction, 2D or 3D drawings, solid surface models, 3D animations, and texture-covered 3D model extraction. It's seen that high-resolution 3D point cloud data is used in architectural survey studies in the production of orthophoto to ready for CAD drawing. In this study, 3D CAD drawings of Ali Efendi Muallimhane, one of the historical and cultural heritage of Konya province, were created from high-resolution 3D point cloud data and their orthophotos. Terrestrial laser scanning technology is a method that samples or scans objects directly, preciously, and automatically, obtaining 3D coordinates with the help of LIDAR technology. It is based on a system that scans the target object in series of points within limited angles in horizontal and vertical directions and enables it to be displayed as point clouds. The location of a point is determined by the time it takes for the LIDAR signal to hit the target and the beam reflected from the target back to the scanner. Scanner-centered polar coordinates are obtained as a result of these operations, and these polar coordinates are converted into Cartesian coordinates. As a result, the point cloud formed by millions of points is obtained. A point cloud is the sum of XYZ coordinates that enable understanding of the spatial distribution of an object or a region within a general reference system. In this study, data acquisition was carried out with the help of TLC Focus 3DX330. This laser scanner is suitable for 3D documentation and land surveys, and it can produce detailed 3D images of complex structures in a few minutes. High-resolution 3D point cloud data is frequently used in documentation studies of historical and cultural heritage, such as survey, restitution, and restoration. In the documentation process of a building, TLC are frequently preferred in architectural facet scans because they provide an accuracy of millimeter level. Architectural documentation studies are carried out within certain standards, thanks to this method in which the most complex geometries of the structures are revealed exactly. The process result relationship in architectural documentation process works extremely quickly. With the transfer of the obtained point cloud data of the object or structures to the CAD program, the preparation of floor plans and section drawings and technical drawing operations can be performed. Thanks to the high quality orthophotos obtained from the point cloud data, 2D technical drawings can be made in architectural survey studies. In this way, the details of the object or the building can be shown on the 3D point cloud data, and the current state of the building can be completed in the form of architectural survey work. The determinate working site called Ali Efendi Muallimhanesi is in Konya province. Today, there are many software, for example, AutoCAD, SketchUp, that offer the opportunity to work on point clouds. AutoCAD software provides certain improvements and enhancements when working over the point cloud. With the point cloud plugin, using clipping tools and existing area on the cloud can be focused and drawings can be made on the cropped area with the help of points. The cropped area includes any objects left within this area along with the crop border. In addition, since these clipped areas now show a cross-section feature, they allow object creation with using point clouds depending on the density of the cloud. Another driving method is to correctly identify the dynamic user-defined coordinate system on the target surface to be drawn. You can see the drawing made using point cloud is shown in below. However, in accordance with the standards accepted in the survey studies, it is not possible to show the details of the building exactly in the drawings to be obtained by this method. This is due to the fact that points in a frequent and complex arrangement do not allow the drawing of the details of the building. In order to make 2D drawings for using survey studies, orthophotos are produced over the desired sections from the point cloud data. If you look at these images, you will see that architectural drawings of building facades made using orthophotos, A back surface, B right, C front, and the left surface of the structure. Preserving cultural heritage is a required study for all civilization around the world. In this study, we present a new method for approach which reconstructs building facade models using TLC data. In addition, the usability of focus 3D laser scanner in architectural documentation studies was investigated. It was concluded that TLC is a suitable method for the documentation of the heritage structure. And with the constantly developing CAD software facilities, the opportunity to work on 3D point cloud data will become easier and the details of complex objects will be drawn more easily. In this way, studies conducted over point clouds can provide different dimensions and new gains to heritage documentation studies. Thank you for your attention.
Okay, thank you for your interesting presentation. Is there any questions or comments?
Sorry, I don't hear.
So
we don't have any questions from the chat section.
Okay, thank you. I have one question. So I think a ground-based LiDAR is very good for the side part of the building's 3D modeling. But how about the top rooftop of the buildings? Is it also good for modeling using?
I'm sorry, I don't understand.
Okay. Okay. So, sorry for.
Thank you.
Okay, let's move. Sorry, thank you again for your presentation. And let's move to the next presentation. So next presenter is Ekaterini Karagianni from Aristotle University of Thessaloniki in Greece. And the research topic is load extraction through satellite imagery processing and visual interpretation. Okay, please share your slides.
Hello, I hope you can hear me.
Yes, I can hear.
Okay, I will share my screen now.
Thank you.
Okay. Hello, everyone. My name is Ekaterini Karagianni. I am a civil engineer, further specialized in geotechnical engineering. I hold a master's degree in environmental protection and sustainable development, and I concluded my PhD at the School of Civil Engineering of Aristotle University of Thessaloniki in Greece. Today, I will present to you my study entitled Road Extraction through Satellite Imagery Processing and Visual Interpretation. First of all, let's take a glimpse of the context of my presentation. I will begin with a short introduction related to road extraction and remote sensing. Secondly, I will introduce the study area and the satellite data that were used. Subsequently, I will present the digital image processing techniques that were applied along with visual interpretation. And of course, I will discuss its conclusions in the end. So let's begin. Road extraction plays a key role in urban planning and city extension issues, as well as in road monitoring and map updating. Technological advances may offer a wealth of data and techniques that could be implemented in road delineation and extraction projects. Among the various methods that have been developed for this purpose, remote sensing techniques could offer valuable information. Especially digital processing of satellite data and visual interpretation could contribute significantly in this direction. This presentation refers to the study of a road network which concerns the city of Kastoria and its surroundings located in northwestern Greece. The long history of the city and its wider area, as well as the spatial structure of the road network in the historic districts of the city center, make this study of particular interest. In the next slide, you can see the study area and its location in northwestern Greece on the left. While on the right, you can see the subset, which includes the city of Kastoria. As you can observe, the city is built on a peninsula surrounded by a natural lake, Lake of Kastoria, which is included in the Natura 2000 network, offering unique habitats for many endangered fauna and avifauna species. The city has a high architectural and urban value, which is depicted in its structure, as there are older parts or newer parts of the city, as well as urban extensions. Rich elements of Byzantine culture, as well as traditional mansions of the 17th and 18th centuries, unique for their architectural design, are located in the city center. In this slide, the satellite data that were used, as well as details about acquisition dates, spatial resolution, and projection information are presented. Landsat 8 multispectral imagery was used in the first step of the study, downloaded free of charge from US Geological Survey with level 1T standard terrain correction and a spatial resolution of 30 meters. A spot maps product was also used, provided by the Technical Services Division of Kastoria Prefecture. This image has 3 spectral bands derived from Spot 5 color satellite images and includes orthorectified coverage at a resolution of 2.5 meters. In order to exploit the information included in satellite images, digital image processing was applied, and specifically spatial enhancement operations, which improve the interpretability of features within the data by modifying neighborhood pixel values based on the value of a targeted pixel. Spatial convolution filtering uses a matrix to average small sets of pixels across the image in order to change the spatial frequency characteristics. Edge enhancement that was implemented in the study delineates edges and makes the shapes and details comprised in the image more conspicuous and easier to analyze. In the next slide, the original multispectral image of the study area, as well as the final image after convolution filtering for edge detection, are presented. And as it is evident, edge detection highlighted urban and linear features, including the road network. For the digitization of various features, classic manual digitization techniques are frequently used as the next step, which, however, can often be time-consuming and tedious. So semi-automatic digitization techniques could also be applied for the extraction of information for satellite images in vector formats, for the digitization, for example, of linear elements and boundaries, such as road network, lake outline, etc. And in this way, the process is simplified while the required time is reduced. For this study, an add-on module software was used in order to digitize the road network of the study area. This is an interactive tool guided by the operator who recognizes features from the screen image. The process was performed in Spot Maps image as it offers higher spatial resolution and consequently higher accuracy in the results. The definite and nearly constant widths, as well as the similar texture along the extension of the road network, were exploited in order to draw ribbon features by center lines. The result of the digitized road network is presented in yellow color in the left image. Boundary features such as road edges were detected through the discontinuity of intensity or color, which indicated different areas, as well as due to the consistent texture, whiter or blacker than the background. Vertices were automatically inserted between the neighboring manually measured vertices based on the underlying raster imagery, in comparison to the classical digitizing method in which manually measured vertices are only used. Image, the area of the city extension is shown. It is the subset of the newer part of the city, which presents a more organized structuring, and therefore it was easier to digitize. So as a conclusion, several methods could be applied to satellite images in order to delineate and extract road networks for urban planning and road monitoring. In the selection of the most appropriate method, several parameters should be taken into account, such as the type of the project, the study area, the available time and the required workload, as well as the final cost and the specialization of the personnel. Therefore, the need to search for easy, fast, and efficient tools is imperative. Spatial filters could be used to sharpen or emphasize the edges in the image, offering effective results, especially in preliminary studies, which do not require special details but must be carried out in a short time. In this study, convolution filtering for edge detection was applied in order to delineate the linear features. The resulting image, after spatial enhancement, presents an improved appearance and is suitable for the delineation of linear features. The road network is effectively highlighted, facilitating the subsequent manual extraction process. Semi-automatic digitization offers results in areas of the imagery where the urban fabric presents organized structuring, such as the area of the city extension. Satisfactory results are also obtained in areas where there is a strong differentiation between the road network and the environment. Road network in cultivated areas, for example, in the mountainous areas of the peninsula or in the bare ground areas. In intricately structured areas, which present a more anarchic structuring, road network of narrow width, for example, and shading interference, the semi-automatic method appears to have weaknesses in digitization, as there are difficulties in finding the edges, for example, at the center of the urban fabric of the peninsula. Similar problems also arise when attempting to digitize sections of the road network with variable width or large differences in texture. Therefore, additional corrections to digitization can also be made manually, combining the semi-automatic with a manual process. In general, although through semi-automatic digitization, the process is facilitated and the amount of non-automated automated workload required when collecting different types of features could be reduced, providing products which could be efficiently combined with other types of data for road maintenance and extension, change detection issues, as well as for cultural or touristic purposes. And closing my presentation, I would like to thank you all for your attention and congratulate the organizing committee for this very interesting online conference. Thank you very much.
Okay, thank you for your very interesting presentation. Is there any questions?
We haven't received any questions for Karayan.
Okay, so in your research, the higher spatial resolution image is better to extract the load. So can we say that higher spatial resolution image is always better than low or medium resolution images? So is there any problems when we use?
In general, I would say that it is better since this add-on module uses this background image as the background to extract information that we need in a semi-automatic way. However, another parameter that should be taken into account is the intensity. So maybe if we have color differentiations, this could cause a problem, even in a high resolution images, spatial resolution. So we have to be more careful when we have to do with these parameters, intensity, color, or differentiations like this in color.
Okay, thank you for your answers.
Thank you very much.
Thank you so much. Okay, let's move to the next presentation. Our next presenter is Chang-hee Lee from Gyeongbuk National University in Korea. And the research topic is construction of 3D modeling based on vertical and oblique UAV imagery for efficient national park management. Please share your presentation.
Hello, can you hear me?
Yes, I can see your presentation, your slide.
Good afternoon, everyone. I'm Chang-hee Lee, and welcome to my presentation about construction of 3D modeling based on vertical and oblique augmented aerial vehicle imagery for efficient national park management. Firstly, I'm going to look at outline. My presentation consists of motivation, introduction, purpose of the study area and flight plan, methodology, experimental result, and finally conclusion. First, we're going to look at motivation of this study. As rapid urbanization progresses from the end of the 20th century, the proportion of forest area, which used to be a large part of the country, has reduced to a great extent. Forest area is an essential element in our life. We need to manage and preserve large area of forest area. In the South Korea, 22 national parks have been designated and managed to preserve the environment, culture, history, and heritage. Although the Korean government manages national park by assigning managers, however, it is difficult to efficiently manage the large-scale parks, which occupy for 6.6% of the country land through on-site survey. In order to solve this limitation, currently unmanned aerial vehicle is being presented as an advanced method for managing national parks. This chart shows the purpose of UAV used by the Korean National Park Service. The UAVs tend to be used mainly for image or video acquisition, such as landscape resource monitoring and providing a press release video. As we checked on the previous page, the purpose of the UAV in national park tend to be biased towards acquire to image only. We expect that it will have a good effect if used for not only image acquisition purpose, but also national park management. For example, at national parks, several problems exist, such as economic losses caused by theft of expensive forestry products or damages of the natural environment caused by illegal campers dumping garbage. This problem is from limitation of manpower management method. UAV has various advantages. The first advantage is UAV can quickly acquire high-quality data about area of interest. In addition, it is possible to produce orthophoto and digital surface models. Second, UAV can equip various kinds of sensors such as optical, hyperspectral, LiDAR sensor on the platform. Using this advantage, we can eliminate the limitation of national park management that I talked about the previous page. It will lead to increased efficiency in national park management. In this study, we construct a 3D model by mixing vertical and oblique images of forest area taken using the UAV. We aim to find high-quality models by comparing between 3D models using various angles of photography and models using only vertical or oblique images. The Yongha campsite in Wolaksan National Park, located in Chungcheongbuk-do Province, South Korea, was selected as a research area for this study. The UAV was used in this study is inspired to model manufactured by DJI and the Genius X4S. The optical sensor was mounted on the UAV platform. For image acquisition, UAV is flown using the fixed body capture application. 2 flight planes were set for each angle to obtain images of the same area. Flight plan 1 is blue line, it means a longitudinal flight route, and flight plan 2 is green line, it means a lateral flight route. The study was conducted in the following process. Firstly, select the study area. Secondly, flight plan and acquire data. Thirdly, construct the 3D models. And finally, analysis to find high-quality models among constructed 3D models. The UAV images were acquired around 1 p.m. on October 22nd and 2020. At vertical image acquire case, set the angle of the camera to 90 degrees. The data were acquired through plan 1 and 2 respectively. At oblique image acquired case, change the angle of the camera to 45 degrees. And as before, the data were acquired for plan 1 and 2. Total of 4 UAV flights carried out. Among them, number of flights 3 was failed to acquire data and were not used in the study. Altitude was set 70 meters and forward overlap and side overlap also were set 80%, and both vertical and oblique images were acquired under the same flight conditions. Generally, the side overlap is set around 70 to 90%. The forward overlap is set at 60%. However, the study area was located in the forest area within the national park. Therefore, many feature points of image cannot be matched during the image matching process. For this reason, to extract more matching points from the images, the flight was carried out by increasing the ratio of image overlap and altitude of UAV. In this study, the photoscan from AGI software was used to construct the 3D model. Among the whole process, image matching process used a SIFT algorithm. This algorithm was used to extract feature points. First, detect points that can be repeatedly selected under location or scale change. Second, assign orientation to detect feature point. Construct a descriptor for image patch around each feature points. Last, third, matching the image based on extract feature points. After that, SFM algorithm is used. The 3D position was determined by using the SFM algorithm and the feature point information. Through this process, it can visualize 3D models at high resolution. Except for the flight plan 2 with 90-degree data that were to be acquired, 6 types of cases were constructed using the remaining 3 types of data. The case was divided into 3 main types to construct 3D models composed of various elements. Firstly, case A was composed using 3 types of data. And secondly, case BC were composed using 2 types of data. Finally, case DEF were composed 1 type of data. Through this table, visual evaluation of the generated 3D model is possible. 6 cases acquired through 4 flights of the UAV consist of a combination of different angle and flight paths. Among the results of generated 3D model, case A, B, C, the campsite area were verified that the 3D model is perfectly constructed. Case D was a lot of data loss on the edge than case A, B, C. Conversely, case EF failed to construct a 3D model in the densely wooded campsite area. In this part, the number of extracted points and dense cloud for each 3D model was compared to verify an applicable case for national park management. Case A, which the 3D model represented the most numerous points and dense cloud in the table. Case F, which the 3D model was represented least points and dense cloud in the table. This table indicated that the more various image was used, the numerous point and dense cloud were extracted. In a 3D model using only vertical image, the information was side texture was mostly distortion of mist. On the other hand, in the case of using vertical and oblique images, the side texture of the campsite was successfully generated. Through this Through that research, we demonstrate that the 3D model based on vertical and oblique images is successfully generated. However, there was a problem of data loss at the edge of the 3D model. It is judged to be a problem caused by not maintaining the degree of overlap on the edge when acquiring UAV images. Nevertheless, the 3D model based on vertical and oblique images can express the detailed terrain as well as trees which are clearly identified as shown on the right side image. In this study, we constructed a 3D model by mixing vertical and oblique images of study area taken using the UAV. To evaluate the constructed 3D models, we compared with 3D models constructed with various components. As a result, the following facts were revealed. First, in the case of using oblique and vertical images together, the high-quality 3D model was generated. Second, the 3D model constructed through this study demonstrate that individual objects of plants and facility in national park can be clearly identified. The expected effect of this study, firstly, 3D map can be used for efficient conservation and management of forest areas. It can save a lot of budget by reducing manpower in the national park management. Secondly, it is meaningful that 3D map of forest area can be produced quickly without additional equipment other than UAV. It will be a great help in disaster monitoring work. Finally, I'm going to talk about our future. For the research plan, we will construct high-density forest model using GCP data together. It could be possible to use in conjunction with other geographic information system data. Thank you for your attention.
Okay, thank you for your presentation. Is there any comments or questions? Okay, no, because since I am also involved in the co-author of this paper, actually I don't have any questions or comments, so we can move to the next presentation. Thank you again for your presentation. And next presentation is from Ojukun Akçay from Çanakkale Smart University in Turkey. The topic is photogrammetric analysis of multispectral and thermal close-range images. Okay, you already share your screen. Thank you.
Thank you, Chair. Hi, everybody. My name is Özgün Akçay. I will talk about photogrammetric evaluation of multisensor imagery, including RGB, near-infrared, and thermal channels. Let me speak first about contents of my presentation. I will mention some recent research to evidence and emphasize the problems during multisensor photogrammetry. Then I describe the aim of the paper. Later on, I will explain the methods which I use to produce three-dimensional data. Then I will share results that compare models and their accuracies. Finally, conclusions will be discussed. When literature has been reviewed, we might clearly see many scientific fields utilize multisensor photogrammetry, such as archaeology, agriculture, forensic, and geology. Most studies generate photogrammetric models collecting terrestrial close-range images or from unmanned vehicles. However, they explain evaluation results separately without relating sensor models directly together. You know, many problems occur during photogrammetric modeling of multisensor images. First, multispectral and thermal lightweight cameras have relatively low resolutions when compared to RGB. Due to low contrast, high blur occurred in thermal images causes failures during automatic image matching, and relatively more sparse and less accurate multispectral and thermal photogrammetric point clouds leads to registration difficulties. Also, quality differences are observed among orthophotos. Beyond technological obstacles, multisensor models have not been considered concurrently. So I compared 3 photogrammetric models obtained with RGB, multispectral, and thermal cameras and examined model accuracies. As you see, I used 14 megapixels Sony RGB camera, 12 megapixels Mapper survey camera, including orange and near infrared channels, and Optris PI thermal camera. And all photogrammetric experiments were carried out on the 1 square meter 3-dimensional test field. The predefined coded targets have been fixed on the test area. As indicated in the workflow, firstly, the coordinates of the control points were calculated on the test field using RGB model. I haven't used any geodetic tools, and then I evaluate photo modeler software has advantages of handling more model coordinate system, while Agisoft more successful matching and orientation. 75 coded targets were automatically measured with photo modeler, then the bundle adjustment process was completed. So first I created model coordinate system using photo modeler, then measurements of 7 coded targets belong to Agisoft software were performed manually. Using the distance between the 2 control points, the model coordinate system was scaled and transformed into the metric system. Later on, multisensor photogrammetric models were created by taking text field images. Finally, all obtained products were optimized and merged. In Agisoft software, XYZ coordinates of control points and their errors were defined as you see in the table. The table shows that the point location accuracies are between 0.9 millimeters and 1.3 millimeters. It provides quite high accurate results. First, radiometric calibration of the multispectral images was performed in order to build quantitative spectral and spatial representations of the test field. The 12 multispectral images were oriented and optimized by the coded targets. Then dense point cloud, as depicted on the slide, were produced using multispectral images. On the other hand, thermal images were processed. Each object emits thermal radiation depending on its geometry and material. So at the top and right image, you see the views of same features in different oriented thermal images. As you see at the right side of the bottom image, purple colors representing lower emissivity, whereas top left corner, brighter pixels representing higher emissivity due to external heat source. 3 photogrammetric models using RGB multispectral and thermal images were reconsidered for a unified orientation and bundle adjustment in order to produce a fusion model. Successively, dense point cloud having obtained as depicted in the left figure. Points of dense point cloud were colored using 3 different sensor images. On the other hand, the mosaic of orthophotos was automatically produced as shown in right figure. The main drawback here is that you are not able to choose sensor type for visualization. It was determined randomly by the software. Some parts contains more thermal patches, whereas others are mostly seen in RGB. So it's absolutely random. When pixel errors were examined, it seemed that photogrammetric measurement accuracies are similar in all image types. The lowest projection errors were accomplished with RGB photogrammetric model, as I expected. It's also observed that manual thermal measurements are better than automatic multispectral ones. However, when metric accuracies are analyzed, it's seen that RGB and multispectral results differ significantly from thermal results. Although RGB stands out in terms of accuracy, the results obtained from multispectral images are also very consistent. But thermal metric accuracies are lower due to large pixel size of the thermal sensor. Tables describe differences of common control points among models. Results of coordinate differences prove that RGB and multispectral models are quite coherent. The comparison of RGB and thermal model indicate that some points have more variances, as you see in control point 6 and control points 2, more variance than other points. Deviations of thermal image points from RGB image can be observed in the right figure here. Dense point clouds were produced from the models, as shown in the model, were also produced. However, thermal photogrammetric model was able to I only produced sparse model, so you cannot see it clearly on the slide on the thermal point clouds. Oriented, optimized, but it's not enough to produce digital surface model. And so orthophotos couldn't be accomplished from sparse thermal point cloud. It's also seen that RGB and multispectral points heights tend to similar distribution when their histograms analyzed. In contrast to the dense points clouds, the distribution of the heights of the sparse thermal points presents low sampling rates. Section 1 and its 4 cross section was determined on the test field. Then Z values extracted from RGB and multispectral point clouds. Z coordinates of RGB is drawn as green lines and multispectral point clouds drawn as red lines. You see the differences. Most differences are observed at the peaks of the test fields. Perimeters and areas of polygons were also compared. Polygons were obtained from 8 photogrammetric point vertices. Results show that all models present significant metric accuracy. And conclusions, radiometric corrections on multispectral and thermal images are important in terms of geometric positioning accuracy. In thermal images, manual point measurement is mandatory, so there is a loss of time and accuracy in model production. In the future, specific approaches need to be developed in order to increase model performance and product quality. Particularly, studies should be carried out to increase the resolution of thermal models using RGB and multispectral camera images. And this is the end of my presentation. You may ask your question if you want.
Okay, thank you very much for your very interesting research, sharing your research. And as you said in the conclusion section, you said radiometric corrections are very important.
Yes.
Especially for summer and multispectral images. So can you briefly explain which radiometric corrections were carried out?
Yes, yeah. Actually, it's a very difficult point to compensate these noise radiometric blur effects, because thermal sensor has not yet as high as technology as seen in RGB or multispectral. So there are some calibration methods to correct their radiometric errors, but we cannot say an explicit method. There are some alternatives, but it's not solid yet. So everybody chooses their own ways. So right now I can't say any valid methodology right now here, but it's really needs improvements at this point.
Okay, thank you very much for sharing your opinion.
You're welcome.
Okay, thank you. And let's move to the next and the last presentation. So last presenter is Halil Ibrahim Senior from Harran University, Turkey. The topic is tree detection from high resolution unmanned aerial vehicle images.
Hello, everyone. My name is Halil Ibrahim Şenol. I'm from Harran University's Geomatics Engineering Department. I will be presenting you today the tree detection from high-resolution UAV images. So, aerial photographs, UAV images, satellite images, and LiDAR data provide us with various information about the Earth, such as the location and characteristics of the vegetation, in addition to the man-made objects such as buildings, bridges, and roads. Collecting, evaluating, and updating the necessary information with other data collection methods other than aerial photographs and satellite images is a time-consuming process, but it is even more costly. In order to ensure the management and sustainability of forest and agricultural areas, relevant information should be stored in reliable databases. According to the type, height, crowd, diameter, age, and shade of the trees are determined. These features are collected through observations and measurements made on the field by going to the relevant regions. These operations in the field cause a lot of time and labor loss. The data contained in aerial photographs and satellite images have long been determined by traditional methods and manually by operators, making these determinations automatically increasing the speed of the project's process and contributes to the reduction of the expenses spent. The data contained in the images have long been determined manually by traditional methods and operators. Making these determinations automatically increases the speed of the project process and contributes to the reduction of the expenses spent. Why the object-based image analysis? Since the pixel-based approach examines only the spectral values of the pixels in the classification phase of these images, which contains intense information, we cannot produce clear data on vegetation and details. Therefore, object-oriented vegetation and object-oriented approach with high accuracy has been used instead of pixel-based approach. Using additional data on object structures, this approach creates meaningful objects by grouping pixels. For that, first we use UAV platform and image data acquisition, image data processing and digital product generation, then tree detection and object-based image analysis. Then we check the accuracy for our analysis export. UAV platforms and image acquisitions. In this study, a quadrocopter UAV with Phantom Dart Pro brand RGB sensors is used in order to convert the image coordinates to surface coordinates in the pictures taken from the air. Signs called ground control points were taken, and these were measured with the GNSS technique. The points are homogeneously distributed as possible. A flight plan has been made according to the designated project area. Flight planning on the route determined to cover the land, longitudinal and transverse overlap ratios were realized as 70% and 30% respectively. Within the scope of the study, autonomous flight height was made at 80 meters, approximately 80 meters height from the ground and with a ground sample distance approximately 2.18 centimeters. Geographical coordinates were recorded on each image using the internal GPS module in the UAV. Images were collected in continuous shooting mode, 1 image per second, at a flight speed 10 meters/second. 256 RGB photos were collected in this shoot. In this slide, you can see the ground control points and the distribution. You can see it's a homogenical distribution in the area, the ground control points, and we use the GNSS tool for the collected ground control points coordinate data. Image data processing and digital product generation. For that, we use SFM, structure from motion. And the structure from motion is a photogrammetric technique that automatically solves the geometry of the scene, camera positions, and orientation without the need to predefine a target network with known 3D locations. In the structure from motion method, a series of pictures overlapping each other are used to create a 3D model. After processing the high-resolution images obtained from UAV with SFM algorithm, RGB orthomosaic images were created. As a result of the analysis, digital products such as digital surface model and digital terrain model containing evaluation information of the study area were produced. Tree detection and object-based image analysis. The object-based image analysis method provides a system that captures object according to distinguishable features such as shape, color, texture, and images. This method provides the availability to distinguish various objects such as trees, buildings, roads, and vehicles. Object-oriented classification method includes segmentation and classification stages. While the segmentation process allows the target classes on the image to be collected in the same cluster, the second stage performs the classification of the object. The most important and first step in object-based classification is the segmentation process. The purpose of segmentation is to subdivide the image and create meaningful objects from the image. After the segmentation process, rule sets for classification are created in order to extract the desired details from the image. After the image were separated into meaningful segments, the features of each segment and the responses to each feature in the image segment were analyzed. In the study, two-class assignment, tree and non-tree, were carried out with object-based classification because the main, basically we need this data, tree and non-tree. We use these indexes, by the way. Accuracy analysis was performed to determine the compatibility of the detected trees with the reference data. Accuracy analysis is the last step in measuring the accuracy and reliability of the classification. As reference data, the crown areas of the trees were obtained manually on the orthomosaic image and compared with the trees determined by automatic method. You can see the digital product, orthomosaic, as we produced a digital surface model and digital terrain model. And you can see this image, the production stages. We can see the trees in greens and the others in black and yellow visualizations. And we can see the extraction of the trees in there. In conclusion, with the development of photogrammetric methods, it has become possible to produce high-resolution structural and spectral data on forest areas using images obtained by UAV. The high resolution of the products obtained by UAV still keeps the field of research up to date. However, most of the studies use UAV data with not only RGB bands, but also near bands. In this study, the performance of only visible bands, canopy height models, multiple resolution image segmentation, and rule sets in tree extraction was investigated. The results show that the tree crowns segmented using spectral information are less accurate than the approach involving the use of a height model. In other words, the use of such as NDSM, sorry about that mistranslation, had a significant effect on the accuracy of tree detection. It was also observed that the density of deciduous or coniferous trees and forest species had no effect on the accuracy of segmentation. Finally, large trees tend to be divided into more segments, while smaller trees tend to split less. The importance of spatial resolution has been found to compartmentalize trees of different sizes. One of the results of the study is different band indexes have an effect on accuracy of tree detection. According to accuracy tests performed at the end of the study, 78% general accuracy was found. Thank you for your attention.
Okay, thank you very much for your interesting presentation. And maybe we have 1 or 2 minutes for discussion. So is there any questions or comments?
We haven't received any comments from YouTube and Zoom so far.
Okay, so you used many object-based indices for detecting trees. So
yeah.
Can you suggest which index is the most useful for detecting trees, in your opinion?
Yeah. Actually, we use many indices. Yeah, you see, but in the NDVI index is most reliable for the green extraction, especially we produce trees from the ground, so we need the green areas. So NDVI is the most reliable one.
So you used NDVI and height information together, right?
Yeah, of course.
Okay, thank you for your presentation. And I think this is the time for closing the session. So thank you again for all the presenters and audience.
Thank you so much, Prof, for your participation, for being a chair in this session. And we are so glad to having you here. And we are looking forward to having you in the following events as chair and as participator with your partners and students. Thank you so much.
Thank you very much for this good conference.
Thank you.
Bye. Thank you.
Thank you. Have a nice evening there.
Thank you. Have a nice day too.
Dear participants, I would like to remind you that our electronic proceedings book is under preparation, under production, since some of the participants didn't attend to the sessions and some of them tried to change, alter some parts of their papers. So we need a couple of days to complete all the book, and we will publish it in our website in a digital format. And on the other hand, probably tonight I will upload all the certificates of contribution to the website again. Thank you so much, and we are closing the session. The next session will start at 4 o'clock in Turkish time. Goodbye. Good afternoon, everyone. Finally, we have reached to the final session of our event, this year's event, and it will be photogrammetry and remote sensing 4 session, which will be supervised by Assistant Professor Dr. Süleyman Sefa Bilgilioğlu from Aksaray University, Turkey. And the registration states that there are 7 presentations. And by the time all the panelists log in into Zoom account, I will assign them as panelists. But the first presenter is here. So, Dr. Bilgilioğlu, the session is yours. Thank you.
Thank you very much. First of all, this is the last session of our symposium, as you know. There is 7 presentation. The first presentation is about supervised machine learning classification in Google Earth Engine, time series analyzing Akkuyu, Turkey. And Ezgi Şahin, you can share your screen and you can start your presentation.
Okay, can you hear my voice?
Yes, it's okay.
Okay. And you can see, can you see my screen?
No, there's a problem. But yes, we can see that.
Okay. Hello, everyone. I hope everyone's health is okay. Today, our advisor, Muzaffer Caniban, and the engineer, Şafak Bozdoğan, and I'm also the urban planner, had studied about, the supervised machine learning classification in Google Earth Engine time series analysis in Akkuyu, Turkey. We have outlines include aim of the study, Google Earth Engine, methodology, which includes study area, image classification, and classified images. And finally, the results include accuracy assessment and land cover analysis. The main target of the analysis is to examine the land use, land cover change in Akkuyu region through the Google Earth Engine platform. And let's talk about the Google Earth Engine. Google Earth Engine is a cloud-based platform where the users can access and process lots of data, remotely sensed data, by using JavaScript and the Python coding and its own interface. And Google Earth Engine has many advantages. The first of all, the platform reduced the operational time of the analysis and repository for the script storing and the sharing with another user. And when we analysis, we have 2 main points actually. The first of all, test the potential of the Google Earth Engine platform and the Sentinel-2 images data with the nearby the nuclear power plant construction. The second main point is compare and assess the performance of the different supervised machine learning classification algorithms. When we talk about the study area, Akkuyu nuclear power plant is under construction power plant and Turkey's first nuclear power plant located by Mersin province. And these images show the construction site with the Akkuyu nuclear power plant, and it's ongoing, by the way. We have a different, we have the image classification frame is about 25 kilometers and 15 kilometers, the classification frame. And after the classification frame, we had analysis about land use, land cover change, implemented 1 kilometer and 5 kilometers buffers centered of the, on the site. As you can see, these images show the Google Earth Engine code platform. The first image showed the area of interest. And firstly, we use the least cloudy composite images, and Sentinel-2 MSI level 2 images. We obtained 3 different years, 2017, 2019, and 2021. And we categorized 5 different land uses, water bodies, built-up areas, agricultural areas, forests, and barren lands. For each classes, we selected the total of the 100 points. 75 of them are used for training, and 25 points are used for testing. And second images show the training points, and the third one shows the testing points. The GIFs are shown the different land use change, land use, land cover change belong to different years. We use 3 different machine learning algorithms: the classification and regression trees, random forest, and support vector machines. After the classified images, we clipped the mentioned buffer frames, as I said, 1 kilometer and 5 kilometer. And you can see the 5 kilometer buffer zones GIFs and the 1 kilometer buffer zone GIFs. And you can see the differentiation of the different images. For the accuracy assessment, random forest classifier has performed silently a better classification than support vector machine and classification and regression trees. Even though classification and regression trees classifier gives better result than the support vector machine, but land use land cover classification map derived from this classifier to be overtrained. For the overall accuracy and the kappa coefficient, the highest accuracy assessment belong to random forest, as you can see. And secondly, the highest level belong to 2021 year. And for the land use, land cover analysis, this table shows the different buffer zones with different years and different machine learning algorithms. These percentages show the forest, agricultural land, built up water bodies, and the barren land percentage. As we can see that support vector machine for the classifier support vector machine with the forest land use, we can observe the forest is decreases per the different years. And the agricultural area, some of the agricultural area increases because of the another barren land open for the agricultural area, and the build-up also percentage also increase for the years. And I'm not sure, yes, you can see the difference. Okay, as a result, Akkuyu nuclear power plant project has doubled to footprint of built-up areas. The project has brought a significant deforestation and filling areas of the seashore, and you can see the water bodies decreases for the different buffer zones because of they filled the seashore with the construction. And the operation nuclear power plant is expected to absorb more population, which may lead to new development areas and more loss in the forest and agricultural land. And these are our references. And thank you for listening.
Thank you for your nice presentation, Ezgi. Is there any question or comments from authors?
No. From Zoom, not yet. But I would like to ask a question, very simple question. What was the motivation behind of this work? Can you describe us better?
Yes, actually, the nuclear power plant is firstly constructed in Turkey, and Akkuyu is the first nuclear power plant. So it's important for the effects of the land use land cover change through the Akkuyu nuclear power plant construction, because the Mersin province has lots of coast and the seashore and coastline has very important for the Mersin, and we can analyze the environmental plan. Also, the Akkuyu nuclear power plant has obtained very residential area, and I think, and the most of users should think that the nuclear effects of the nuclear power plant is important for the land use land cover.
Thank you so much.
Okay.
That was a missing point. It's a very crucial and key point in the presentation, so that's why I wanted to emphasize it. I have received no question.
Okay. Thank you very much. In addition, that I want to say something in this point. The future of the remote sensing, all authorities say that free data, free software, and free app. So the cloud computing is very important in that point. I think you can go in this way. It's the good, I think. Now the second presentation of our session is the title is Analysis of the Effect of Training Sample Size on the Performance of Two-Dimension CNN Models. Elif Özlem Yılmaz, I think, the presenter. You can open your mic.
Hello.
Hello. Elif Özlem Yılmaz, you have 8 minutes for your presentation.
Okay.
And then we will maybe get some 1 or 2 questions.
Okay. Hello. I am Elif Özlem Yılmaz. I would like to start with presentation. The title of study is Analysis of the effect of training sample size on the performance of the 2D CNN models. First of all, I would like to presentation. It includes the 5 main topics. 5 main topics. They are introduction, CNN, study area, and data set, results, and conclusions. Okay. Hyperspectral remote sensing plays a significant role in the research of the Earth observation, owing to rich spectral information. This type data is in the big data category. Therefore, traditional methods are limited in the evaluation of these data. In the recent years, deep learning has become a popular application in remote sensing as they handle complex problems. Compared to traditional classification methods, deep learning models have achieved higher accuracy in classifying the hyperspectral data sets. Why is the deep learning approach preferred so much? Since the architecture of the deep learning model is flexible, this has a positive impact on the learning ability of these architectures. Another reason is the development of the CPU hardware of computers. On the other hand, deep learning has this advantage that learning models behave like a black box, because this initial process in the model are not known. The aim of study is that the effect of sample size on the performance of deep learning model was analyzes hyperspectral data for classification problem. In addition, thematic maps were produced with different number of samples, and the accuracy of the thematic maps were compared. CNN model has been widely used as an architecture of the deep learning model. The main difference of the architecture of CNN model from the other neural network is that it includes the convolution filter. This filter has a great capacity to extract the feature of the deep learn, big data. The architecture of the CNN model, a feed-forward neural network, consists of several combinations of the dense pooling, flattening, convolutional, and dropout layers. The dense layer connects neuron in the previous and next layer. The pooling layer reduces the large data but keeps on the significant information. In the flattening layer, converts the multidimensional properties into the one-dimensional vector. Moreover, the dropout is used to prevent overfitting in the deep learning models. In this study, Power University's perspectral dataset was used. It was obtained by a ROSIS sensor, which has 600 to 3040 pixel with 1.3 meters spatial resolution. The original dataset includes 115 spectral bands, but 12 bands were removed because they comprised the noisy data. The reference data set of Pavia image was generated for the 9 major land-use land-cover classes. Before the classification, the first step was to randomly divide the dataset into the 3 subsets. The first one is training dataset with 75% of the samples. The second one is validation dataset with 15% of the samples to evaluate the overall accuracy of the thematic maps. And the third one is the text dataset with 10%. Moreover, 15, 100, 200, and 400 samples for each reference class were randomly selected from the training dataset. It should be noted that the application classification was performed using the Jupyter Notebook with Python language. In order to build the user-defined model, input, batch normalization, convolution, flattening, dropout, and dense layer were generated. It should be noted that a patch size of the 5 to 5 was chosen for the model. Moreover, the training data set was according to determine the patch size. In order to train the deep learning model quickly, the training data set was normalized before the training stage. The unit of the dense layer were chosen as 16.4 and 128, considering a trial and error approach. Moreover, the activation functions of ReLU and softmax were employed in the processing stage. The produced 4 thematic maps presenting the 9 land-use land-cover classes were generated. To analyze the accuracy assessments of the thematic maps, the overall accuracies and couple coefficient were calculated by using the reference data set. The highest overall accuracy, 95.36%, belongs to the map produced with 400 samples, while the lowest overall accuracy belongs to the map with 15 samples with 86.94%. Furthermore, the F-score values were produced to evaluate the estimated accuracy of each land-use land-cover class. As can see in the table, the land-use land-cover classes which the highest F-score value was calculated for the painted metal sheet for all numbers of samples combination, and shadow classes except for the case of the 15 samples. The land-use land-cover classes with the lowest F-score values belong to bare soil for 15 samples. From the visual analysis of the thematic map produced, it was observed that the meadow and bare soil classes were mixed together due to similar spectral characteristics. The thematic maps created with 100 samples had the lowest F-score values with bitumen and bare soil classes. Moreover, it observed that the bare soil classes mixed with meadow class in the thematic map produced with both 200 and 400 samples. Training times for different size of training samples were recorded and shown in the table. The lowest training period of the model took about 930 seconds for 400 samples. The reason could be related to the large sample of the data set employed during the training. The 2D CNN model with the 400 samples resulted in the significant increase in overall accuracy, approximately 90%, particularly compared to 15 samples per class. The finding in the study relevant that the samples per class employed in the training stage of the 2D CNNs can have significant impact on the achieved accuracy. Poor performance were observed for the cases where limited training data were available for the training. Thank you.
Thank you so much. Your very interesting presentation. Is there any question about this title?
I have.
Okay, you can ask.
While I was trying to assign the panelists, I missed the programming language and the library that you use for CNN. Which package did you use?
I used the Keras library and scikit-learn for the evaluating the accuracy.
Could you open up the latest table in the results section?
Okay.
As you can see, the accuracy is slightly increasing when you use 400 samples, but the training time is kind of logarithmically increased. I think that there should be a sort of overtraining when you use 400 samples, because the more the samples we use, the more risks that we have an overtraining. So did you check by your visual interpretation whether there is an overtraining or not? Because for instance, in the previous presentation, when they used a cart, even though they obtained a higher accuracy with respect to support vector machines, the total LULC map was totally mixed up. Did you do such a visual interpretation after your classification?
Thank you. Okay.
Okay, is there any question?
That was a question, actually.
I'm sorry, your voice very low, so
Okay, did you do any visual interpretation after applying the classification with 400 samples? Because it seems a bit overtrained for me.
Actually, I did checked in this classification, so I couldn't answer this question.
Okay, I recommend you to do it, because sometimes the accuracy results can be high, even though pixel classifications can be mismatched because of the overtraining.
I know. Okay, I will check. Thank you for your advice.
Not at all, not at all. Okay. It has been a good presentation. Congratulations.
Thank you.
Yes, and you can also do another evaluation about not only overall accuracy and kappa coefficiency. There's another type of algorithm for the accuracy measurement.
Okay.
You can look of them.
Okay, thank you.
Okay.
ROC curve, for instance, ROC curve.
Yeah.
Am I right, Sefa? ROC curve.
Yes.
Alternative.
ROC curve.
Yeah, ROC curve.
Yes, ROC curve.
Okay. Thank you.
Yes, the next presentation is from Hasan Bilgehan Makinacı, but there's a connection problem, I think.
Yeah, he has a connection problem. Even though he comes frequently, he loses.
Yeah, maybe we will go on the other presentation. Then, if he come, they will present their presentation.
Fourth one, Bachi, I think.
Okay, the next presentation is extraction of high precision build-up areas from Sentinel-2B imagery via multi-index approach and fuzzy C-means algorithm by Imane Bachri. Imane Bachri, are you there?
Yes,
Yeah.
hello everyone.
Hello, you.
Can you hear me?
Yeah, we can hear you, but you can open your cam also.
Okay.
Okay.
May I share my screen now?
Yes, it's okay. You have 8 minutes for your presentation. You can share your screen and you can go.
Oh, okay, thank you. Can I start now?
Yeah, you can start. I'm sorry, I'm with me.
Hello to everyone. First of all, I would thank you for accepting my presentation. I'm Bashri Iman, Doctor of Hassan II University of Casablanca, Morocco. And then I will present our work, which is entitled Extraction of High Precision Built-up Areas from Sentinel-2B Imagery via Multi-Index Approach and Fuzzy C-means algorithm. In this presentation, I will follow the following outline. I will begin by introducing the context of the study. In the second part, I will present the problematic and objective. In the third part, I will present study area. And I will focus in the fourth part on data and methods. And after, I will present our results and discussion. And finally, I finished by conclusion and perspectives. Although urban areas make up a small percentage of world's total land and population and density of population, their and resource use rates are much higher than in surrounding areas. Can you hear me now? I think it's a problem of connection.
No, there is no problem. We can go on.
Okay. Necessitating better resource management practices. Understanding the spatial distribution and development of urban area is critical for urban planning and research. And mapping the built-up area is among the most basic tasks needed for this. However, the urban areas detection faces difficulties in arid and semi-arid lands. Indeed, the extraction of built-up urban areas using high spatial resolution multispectral imagery such as Sentinel-2 remains a significant challenge due to spatial confusion and intra-urban variability with other type of land cover, especially between built-up areas and bare land. For that, our objective is increase built-up accuracy by using 5 spectral indices for built-up, which is NDBI, NDTI, NDVI, DBI, and DBSI by means of fuzzy C-means algorithm. As a study area, we have chosen Tantan City, which is located in the southeast of Morocco, 33 kilometers south of Agadir city. This city characterized by semi-arid Saharan climate with hot summer and winters with low rainfall. We worked with a multispectral image of high spatial resolution Sentinel-2B of level A with the UTM projection zone 29 north, taking into account the reference system WGS84. Now we will move into our methodology, which have based and which consists of several steps. First phase is the pre-processing of the data, including atmospheric correction and resampling. The second is the combination of this correction and with is the combination of these indices before classifying them. And finally, the extraction of urban areas by means of fuzzy semi algorithm and evaluation of the results. We has worked as indices with the NDBI, DBSI, and NDVI, Bersoi index, BSI, normalized difference tier index. For the combination between multi-index combination based on the correlation between the 6 spectral indices, the spectral difference in the 3 main land cover classes, bare land, vegetation, urban area could be expected to increase by overlaying to the third combination, DBSI, NDVI, NDBI dataset, and BSI, NDVI, NDTI dataset. As we can see, the 3 results of classified Sentinel-2B, DBSI, NDVI, NDBI dataset, and BSI, NDVI dataset created via fuzzy semis algorithm generates different results. We noticed that Sentinel-2B generated an overall accuracy of 53.71%. The DBSI NDVI has 85.28%, and the BSI NDVI NDTI has 83.99%, which means that the best data set is BSI NDVI NDVI. As a conclusion on this work, several points were noted. The multi-index dataset developed the BSI NDVI NDVI derived from Sentinel-2 for built-up mapping using fuzzy semis algorithm show a high accuracy, rapid, and automatic classification of built-up area with an overall accuracy 85.29% and kappa coefficient 80.89. Such a result is explored the ideal multi-index dataset and data mining technique, which could be very helpful to identify the built-up area with accurate information in dry season. Therefore, the planners and decision makers can quickly recognize and make an estimation of built-up area states to cities in dry land. As perspective on this work, the dataset developed in this study, we're going to test it in other area with high land cover heterogeneity in rainy season. Also combine other spectral indices that can improve classification mapping. We expect to incorporate multipolarization SAR Sentinel-1 data in order to use this data to differentiate between bare land field and built-up areas. Thank you for your attention.
Thank you very much, Mrs. Imana Bakri. Is there any question or comments for the presenters? If you have a question, you can write in chat or you can ask. Yeah.
I suppose that we don't have any because I checked also YouTube.
Okay. Thank you very much again. The next presentation of the session is the availability of local laser technique in forest management planning. I think Mrs. İldeniz Leyla Öztürk will present, or
who's going to present? Mücahit Emre Oruç?
Mücahit Emre Oruç, okay. Okay, Mr. Mücahit, you have 8 minutes for your presentation. You can share your screen. Okay, you can go.
Hi, good afternoon, everyone. Let me introduce myself. My name is Mücahit Emre, and I'm continuing my education in machine learning and GIS from the Mersin University. Today, I would like to talk to you about usability of terrestrial ladder technique in forest management planning. My presentation outline introduction, forest management planning, study area, material and method, file and office work, result consultation. Introduction, forestry studies are activities that are carried out in a wide range of long-term and contain difficult conditions. There is an important need for information the realization of these activities, which consist of planning, this decision making at management stage. Considering the historical development of forest management in Turkey, many studies have been carried out and necessary steps have been taken in this direction. Today, in parallel with the advancing technological developments in these studies, different and new methods have been used in addition to the classical methods from the past. The latter method offers high resolution data registers of the sparse and dense forest area. In this context, terrestrial laser scanning using LiDAR technology was used in the study area determined in the study, and the data belonging to the area were obtained precisely and quickly. Forest management planning. Forest management is a science that investigates how, when, and with what criteria forests can be used and how to obtain more efficiency from the forest in the order to ensure the continuity of forest. Study area. As the study area, measurements were carried out in forest area within the Mason University Çiftlikköy campus. Material and method. The terrestrial laser scanning method was used to the study with the laser beam emitted from the laser scanner device. The distance between the object and the device is measured. The point cloud of the scanning area can be obtained and 3D models of the desired object can be produced. Point cloud data contains information such as location information, density information, RGB value, scanning angle, number of reflection, and length of reflection. Field work. The laser scanner was positioned to take the drawing part of the trees from every angle with gradient sensation, and the measurement process was complete in 11 sensations in total. And diameter measurements of determined trees were made at the heights taken as reference. Office work. Pharo-Sync software, which is a commercial software, and various programs were used in the process of data processing. The scans made by processing data in the software were combined. As a result of the merging, the 3D point cloud of the study area was obtained. Result. Volume calculations were made in cloud compare and reconstructor software with the obtained point cloud data. In addition, in order to compare the volume calculation, the volume was calculated with the volume calculation formula used in forestry and the Huber method. Volume calculation and comparison. Table 1, calculation obtained by spatial measurement. Table 2, volume calculation obtained by cylinder pacing method in cloud compare software. Table 3, volume calculation of spatial measurement with Huber method. Table 4, result obtained from the formula used to calculate the volumes of trees. And finish table comparison of numbers 1, 3 volume among the method used. Consideration. In the study, since the forested area was preferred, the point cloud obtained was combined with high resolution and low error to obtain a point cloud and a solid model. However, it has been determined that a single software is not sufficient for software. With the result obtained, error values were calculated and values very close to the result obtained by local methods were obtained. Since more area can be scanned in the short time in the terrestrial ladder scanning method, and the volume calculations of trees will be calculated more easily with the software used. The usability of the terrestrial ladder methods is investigated. Thank you for listening.
Thank you for your nice presentation, Mr. Oruç. Is there any question about this topic or comments? Okay, there is no, I think.
Thank you very much for everything.
Yeah, we thank you.
No questions received from YouTube too. I think Bilgehan Makineci is there right now. We can proceed with him if you want. It's your decision.
Can you hear me, Chair?
Yeah, we can hear you.
I'm sorry if I'm late because my lesson have finished yet. So I will represent our study now.
Okay, okay, Mr. Makineci, you can open your cam also and you can start your presentation.
Just in a minute.
Okay, the topic is this presentation is documentation of cultural heritage with backpack LiDAR usage on photogrammetric purpose. You have 8 minutes for your presentation. You can share your screen and...
Screen, yes. Is it okay for everyone?
Yes, it's okay.
Just a minute, sorry. So, hello everyone. I suppose for each of all are well done and healthy nowadays. Kasım Erdal and me, Hasan Bilgehan Makineci, from Konya Technical University are going to represent our study now. The topic, documentation of cultural heritage with backpack LiDAR usage on photogrammetric purpose. I hope enjoy it. This is the representation plan, which we now represent. First, we start with defining the problem of the research, and then what is the aim and motivation of the study we talk about. Then materials and methods used in research we talk about. Some little discussions after results, and let's finish with conclusion. Well, we start with problem definition. So Anatolian lands have many civilizations throughout history. All cultural heritage left by civilization is an essential document for researchers. The most important part of the theory of cultural heritage is considered as historical artifacts. Historical artifacts are subjected to deliberate or unconscious deconstruction by natural causes or human hand over time. Architectural documenting is essential requirement to identify the evidence of historical artifacts, be instrumental in their transmission to future generations, and document the destructions they have suffered. So the aim and motivation of the study, with photogrammetric methods in recent years, a new perspective has been given to survey investigations. The data obtained with 3D modeling can be collected in the digital environment and presented visually. The modeling historical artifacts and external and internal structures together is a test that can be done with many sessions with classic terrestrial laser scanners, TLC. Backpack LiDAR systems are properly newly applied alternative method, and historical buildings where many sessions should be held with terrestrial laser scanner systems. It's a better idea to use it. These systems quickly acquire coordinates data and omega kappa phi angles difference with GNSS IMU systems and save time and cost following photogrammetric mentality. Actually, in this research, using backpack LiDAR systems, the exterior and interior structure of the village mosque, Dumanoğlu village mosque, which is an Ottoman artifact built in 1899 in Şiran district of Gümüşhane city, was modeled in 3D with its integrated camera. The backpack LiDAR have been colored the point cloud and made suitable for architectural survey studies. This is the study area. Historical village mosque belonging to Dumanoğlu quarter, as I said, in Gümüşhane province, located in the east of Black Sea region, and this is also Silk Road for caravans at the Empire Age, and it is important mosque for the caravans to pray there, and the workflow. I want to talk about workflow. There are ground control point GCPs in the field work and operations for LiDAR data. At the office work, the office work includes adjustment of GCPs and analysis of point clouds. Thus, the steps of workflow: first, pre-process for field work; the second, data acquisition; third, evaluation of point clouds with ground truth data. I can say. The backpack LiDAR systems specs on the table, as you can see. The Green Valley backpack LiDAR systems, DCG-15, was used in the study. Unlike the general, the Lie backpack LiDAR has two laser sensors. One is horizontal and one is vertical. With a panoramic camera and GNSS human receiver. GNSS receiver in the LiDAR system integrated with point data, and point data is obtained in the coordinates during the sessions and held in the outdoor dimensions. So this is the profile of LiDAR scanner. Lee backpack. Now you can see GNSS camera integration and some main body components. The GNSS receiver in the laser scanner works with post-process kinematic (PPK), while providing access to satellite data required for PPK. The ground station operating with static method is used to simultaneously. In this way, the horizontal position of the obtained point data can be obtained up to 7 centimeters. The outcomes. Our outcomes in internal and external data cloud, point cloud of data. sorry. The external scans of the mosque was completed within approximately 6 minutes, and approximately 2 million points were obtained in the external scanning. And the second one is internal data. The internal data completed within 4 minutes, and approximately 800,000 points were obtained in this scan. Also, our some more outcomes. This is the table of error values created with GCPs. There is approximately 4 centimeters vertically and horizontally mean error. Horizontally maximum error is also like 8 centimeters, and minimum error is 2 centimeters. Vertically, it's like 4 millimeters minimum, and maximum 7, like 8 centimeters maximum also. And we have a discussion about that. Laser scanners, terrestrial laser scanners, are used for historical artifacts, archaeological environments, etc. It's frequently used in many modeling studies. TLCs are installed at the many points in the area to be scanned, so field work takes a more long time. These increase in the number of process in office works takes a long time due to efforts to combine the point clouds obtained from different points. So also we can save the point accuracy and the number of process time we can save with LI backpack LIDAR. We can say. So this is the conclusions of the study. This study aimed to determine that documentation and modeling of historical buildings can be carried out quickly and effectively with backpack LIDAR. And the average of horizontal error is about 5 centimeters, and the vertical is 4 centimeters. This shows that the study results are adequate. And well-to-do results have been demonstrated with the field works and office works carried out of this purpose. And this is the last for me. Thank you for all listeners.
Yes, thank you for your presentation, Mr. McNichie. Is there any question about this topic and presentation? Yes, you can write from YouTube or the chat site. Okay, there's no question, I think.
Thank you for everyone.
We thank you
I'm
for
late. I'm sorry again.
It's not a problem. Yes, the other presentation is from Mr. Altunel, I think. Mr. Altunel.
He's right there.
Yeah, okay. The title of the presentation is Monitoring the Stability of Highway Cut Slopes Utilizing Drone Photogrammetry.
Yep, I am unable to start my video, and it says it is stopped by the host has stopped it, it says.
Okay, I will, maybe Secretary Dr. Iban, I'm not host in this session. Secretary will manage them. Okay, we will wait. Okay, it's okay, I think.
That's fine.
Yeah, you have 8 minutes for your presentation.
Okay. I'm Arif Oğuz Altınel from Forestry Faculty, Kastamonu University. And before starting, I would like to apologize in advance if I stay stagnant and cause misunderstanding due to mispronunciation and so on. Title of the proceeding is, as shown in the first slide, monitoring the stability of highway cut slopes utilizing drone photogrammetry. Roads have been the lifeline of human civilization since the ancient times. This is the Gümüşhane Ring Road between Erzurum and Trabzon. The example is that. And when they are built with the accumulated knowledge, tried and tested for the last 100 years or so, they serve flawlessly. And this example is from Gümüşhane, double-tubed Sabuncu tunnel. However, if the engineering aspect is undermined, the results will definitely be costly. This is a recent failure from Zonguldak. It was aired in all TV stations. As you can imagine, Turkey is a rather treacherous country. Not everywhere is like Konya Plain. When the roads are built on uneven topography, the most common accompanying complement a road needs is either cut or fill slope strengthening. These are some examples to the slope fortifications. The first one from the left in the first row, gabion wall strengthening, rock formations, galvanized steel mesh, etc., etc. The most common slope protection, on the other hand, is simple retaining walls. See the one I don't. See the small one on the cut slope. This is the cut slope area, and another one right at the top of the fill slope. Oops. And these are also the measures we often see failing. These are from the examples from the US, Manhattan on the left, and UK on the right. We located 6 such cut slopes on Kastamonu-Karabük Intercity Road. This is the most frequent place we as a family travel on. And 6 such slopes were selected. Both our investigation and the literature said, or we read through those, there were 3 slope categories. Below 87% is safe all the time. More than 87%, but less than 148% is critical. And more than 148% fail certain classes. And we thought, let's go ahead and measure those. But how we are going to measure them? We had a total station, a nice one, but we thought it would take hours and days, maybe more than that, to get the precision we would need for such a study. Therefore, we opted to go with drone. This study took place in 2018. So the DJI Phantom 3 Professional was the low-cost, achievable drone back then, and we used it to model the slopes. First, an orthophoto was made. Today, everybody knows how to make those, so I'm not going to get into the detail. Then transform the orthophoto model into a raster dam and cut the area in question with rather high spatial resolution. When the most successful space-borne dam, Tandem X 12 meters, is considered, the UAV, the capability of UAV produced dam, which is 22 centimeter by 22 centimeter, in this particular example, can better be understood. Then slope classification was carried out for 6 of the cut slopes according to the classes specified earlier. And the models were generated. Please notice the amount of yellow and red areas. Those are, the red is the critical, yellow is the critical, red is the fail certain areas. This was in 2018. If we were to go to the same cut slopes and measure them one more time today, the amount of red areas would more than likely double or triple the amount in 2018. Finally, we calculated the acreages. In such common slopes, you don't expect to see the red areas, which is class code 33. Because when the disturbances are observed, the preventive measures to stop the problems must have been applied. However, in such slopes, there was no measure apparently because they were crumbling. And the results we got from our study were these. The slopes had looked extremely steep to begin with, and the analysis showed considerable amount of slope area in each question cut slope was on critical to fail certain gradients. In each of the question cut slopes, no slope stabilization work was observed other than the gravity retaining walls at the slope's toes. Due to constant exposure to seasonal rain, snow, wind, etc., particle bonding agent was inside the sampled slope soil. I am, in this presentation, I am partially giving the results of the entire study. We also analyzed a lot of soil samples, but that part of the study is not related to the concept of the symposium. That's why I omitted those. Due to these steep slopes, no vegetation was naturally taking hold on to the slope surfaces because they were rather steep. Any seed which might happen to land on the soil is swiftly washed away with the coming rains, which are frequent in Kastamonu and the Black Sea region. Therefore, a human-induced vegetation initiative looked to be the cheapest and the long-time effective solution to stabilize those common cut slopes. But as of 2021, there is no such precaution, and they are still crumbling. We are seeing those as we travel through the same road. So there is not much attention is paid to these types of common cut slopes. This is the last remark I can get out of this study, and I would like to convey my gratitude to Dr. Yakar and his team for organizing this lovely symposium, and thank you for the opportunity. Greetings from Kastamonu. That's it. Thank you.
Thank you very much, Mr. Altuner, for your nice presentation. Is there any question or comments for the presenters?
Maybe before getting a question, I can add something else as well. I gave the example of 22 centimeter resolution, but it was not a constant resolution in all of the cut slopes. We managed to decrease it down to 9 centimeter, but no less than that. So UAV capability is endless as of today, but the area remains relatively small compared to aerial or spaceborne methodologies. But again, for small things, it is very practical.
Yeah, of course, drone is the very high resolution for us. And the slope is the very important data for us for landslides or disaster management. We thank you for your nice presentation again. There is no question, I think.
All right.
We will go the next and the last presentation of our session and our conference. The title of the presentation is Using Drone Mapping to Analyze Risky Areas and Predict Land Use Land Cover and Shihang Island, Coimbatore Province, Thailand. Mr. Shuatharapong will be presented.
Okay, I'm here. I'm ready. Can I share screen?
Yeah, you can share your screen now. Yeah, you have 8 minutes for your presentation. You can start.
Okay. Good afternoon, everyone, and good evening from Thailand. My name is Commander Suvatharapong Surasan PD. I am a master degree student from Thailand. Really, I am a Royal Thai Navy, but I get a scholarship from Burapha University, Thailand, and Wuhan University, China. Today, I will show my topic, using drone mapping to analyze risky area and land use land cover at Sichang Island, Chonburi Province, Thailand. This is the outline. There are 6 steps. 1. Introduction. Why I select the Sichang Island? There are many islands in the Thailand, but Sichang Island is very high potential for development. the distance not far from the Bangkok, not far from the mainland. Bangkok is a Thailand capital city. And it's very important, Sichang Island reality about the Thai government policy to raising the economic. Why is the drone? When we see the Sichang Island, it is not different, but when we zoom in, drone is the best. The another benefit from the drone, such as economical, it's easy to find, accuracy, time scale, and operation in hard to reach area and can capture image under the cloud. Two objectives of the research. One, assessing the location of natural disaster risky area, landslide and flood. And two, predict land use land cover for next 10 years. Research scope. Administrative boundary only the Sichang Island. The information in year 1999 to year 19 focus only Sichang Island land use land cover. And where the Sichang Island, where's Thailand? Okay, this is the Merchant University. Let's go to Thailand. Okay, it's around here, located in the Gulf of the Thailand. 3. Conceptual framework. There are 5 steps: area study, data collection, data processing, data analysis, and the conclusion. For my thesis, the heart of the thesis is the second step, data collection, because I select the drone method to collect the drone data. After that, we will generate the base map. And many things begin from the base map from drone. 4. This is a design method. 4.1, data source. I select the data source from the Landsat 5, Landsat 8 from the drone, and auto RGB area photo from Royal Thai Survey Department. And next, creating very high resolution image of Sichang Island by flying drone to capture mini image. I flying all one day on the Sichang Island. There are 6 steps. At first, I select DJI Phantom 4 and selecting the drone application DJI Go 4 and pick 4D mapper. After we finish flying the drone, we will get many the raw data. I manage it in the pick 4D mapper to create digital model of Sichang Island. Use the theory about the mosaic. In this step, pick 4D mapper mosaic editor step, we will get the very high resolution image. The resolution about 7 centimeters. I flying drone altitude about 200 meters. So it means I can classify or identify many objects in this island. After that, digitizing by use drone image is the base map, such as the road, the street, the urban, like this. And creating mini FGDS layer by digitizing from the drone image. And next, use auto RGB Sichang Island's base map in year 99, year 09. Resampling half meter to 1 meter and resampling the drone 7 centimeters to 1 meter because this is the requirement of the CA Markov model theory. Next step, studying land use land cover. For the Sichang Island, I classify by my visual, identify the polygon, forest, miscellaneous, urban, and built-up water body. At first, I generate the shapefile memory from digitizing drone image. After that, I digitize the urban, water, forest area, and union the tree type. Bring the boundary polygon to L with the tree type. The result is the last one type, miscellaneous. And union the polygon again. And convert to the raster file. And now we ready to calculate the next step because we get the land use land cover Sichang Island resolution 1 meter. And next, assessing the impact of natural disaster risky area, landslide and flood. I use the equation S equals summation WI multiple RI. When S is the dip area, W is the weight, and I is the factor capability. I find the weight in AHP online system to find the urgent vector for the flood. There are the 7 criteria: precipitation, slope angle, land age, land use, lithology, distance from the water source, and DVI value. The maximum urgent vector is the precipitation. For the landslide, it's same the 7 criteria, but change the precipitation to criteria elevation and the drainage value to contrast between landslide and flood. The maximum urgent vector is the drainage. After that, we manage it, the ArcGIS, use the map, algebra expression, use the weights to multiple with the value. So now we get the Fat-Lisky map and landslide-Lisky map. And next, raster calculation again. The last one, we will get the compact Lisky map. For the next objective, predict land use land cover in year 29, based map from the drone map in year 19, use the CA Markov model. After I manage many things in the GIS, and next for the CA Markov model, I manage it in the ODC Server program. This is the CA Markov framework. In the first step, Markov chain, use the base map in year 09, compare year 19, the time, the gap time period is 10 years. It means we will calculate the next 10 years in year 29. The next step, the CA Markov model, we change the base map to year 19 and bring the conditional probability map and transitional area matrix to calculate too. The last one, we will get the map in year 29. Compare the accuracy checking between drone and the landsat image. You know, the landsat image is resolution about 30 meters or 15 meters, but it's not enough. The accuracy about drone is very high, 93.61%. The accuracy from the landsat is low, 62.68%. Output, we can know the location of the risky area. The color green, yellow, red is the low, medium, and high risky area. And the area predict land cover for next 10 years. The forest, miscellaneous, urban, and view-up water body is the color green, gray, red, and blue color. And this transition area metric. 6. Conclusion. Compact risky area map interpret landslide and flood. Have high risky area about 2.9%, which has the community area in this risky area with a total of 1 village. The Thai government agency at Sichang Island should prepare the plan to accommodate future disaster situation. And next, the result about the CM Markov model for predict next 10 years, the forest to slightly to reduce, miscellaneous to reduce, the urban area to increase, and water body is not changed. What it means is indicating that there is an enlargement of the city. The government should use the budget to support the construction of the road and public utilize to support the increasing number of the tourists, transport and goods, environmental protection, and planting to eliminate waste caused by the tourists. And the last one, I'm proud to present bird eye view for the Sichang Island managed in the PIC 4D mapper. Thank you for your attention. Thank you very much.
Thank you. Thank you very much for your nice presentation. Is there any question or comments for the presenters?
Okay.
Dr. Johnny Ban.
We haven't received any questions on YouTube. And Zoom, no.
Okay. It's the last presentation of this session and this symposium. Thank you for all audience and attendance. And also I would like to thank for the organizing committee for this successful and lovely conference. And also the secretary, Dr. Janiba, I would like to thank you again for your high effort, I know.
Thank you so much. Thank you so much, Stefan. Actually, we had a storm outside, so we lost the electricity, internet, everything, and the connections. So it was very hard to reconnect again. So if you want, we can conclude the whole conference.
Yes, we will close the session and all conference.
All the conference. Dear participants, thank you so much for your participation and contribution. All the presentations have been so fruitful and very effective, efficient ones.
Yeah.
So thank you again. We are looking forward to seeing you in November 2021. 6 months later, we will have again another IGD conference series. We will publish all the details for the following event approximately in September. And then we are looking forward to your participation again with lots of presentations. We are also considering these series in online versions since we cannot imagine or foresee the situation of the pandemic worldwide. We consider that these lockdowns, travel restrictions will continue. So the November conference will be also online like this. So that's the case. The certificates and the proceedings book will be published in our website in the following days. Please follow the website for these kind of documents. That's all. And give our regards to all the colleagues worldwide. Thank you.
Thank you. Have a good and healthy days.
Thank you. So we are